will allow the spacewalkers to propel themselves back to the International Space Station in the unlikely event that they were to become untethered during this time. Over to the left, you see NASA astronaut Andrew Morgan. He'll be EV2 for today's spacewalk. The duo will be completing, again, the third in a series of repair spacewalks for upgrading the alpha magnetic spectrometer with a new pump system. So far, the two spacewalks that have preceded this one have been really in preparation for installing the new pump system that will carry the alpha magnetic spectrometer through the life of the station, providing the necessary cooling by carbon dioxide that will allow the experiment to run and collect billions of particles from the cosmos. Again, you see Christina Cook, NASA astronaut to the left, inspecting some of the SAFER unit's configuration. She is the lead for the suit-up activities, has been leading the crew through most of the morning through the pre-breathing activities to get them set up, purge the nitrogen from their bodies as they'll be breathing 100% oxygen through the duration of today's spacewalk. She's assisted by NASA astronaut Jessica Meir. Jessica Meir aiding Cook through the suit-up activities, but for the most part, Meir's activities through the duration of today's spacewalk will be controlling the station's robotic arm. Luke Parmitano, who you see the suit in the red stripes, again, he'll be EV1 through the duration of today's spacewalk. He'll be at the end of the station's robotic arm through most of the activities today to grant him the necessary access of installing that new pump system, as well as swaging some of the tubes. There are 8 tubes that will be needed to be swaged throughout the duration of today's spacewalk to completely mate the existing pump system, the cooling system, with the new pump. Andrew Morgan, his primary duties will be assisting Parmitano through these activities, carrying some of the tools specifically designed for these EVAs, for these spacewalks, and aiding Parmitano as he will be having the necessary access at the end of the station's robotic arm to reach some of the tubes and make the necessary connections with the new pump system. Again, the purpose of today's spacewalks is to repair the alpha magnetic spectrometer. This experiment was installed back in May of 2011 on STS-134. Space Shuttle Endeavour delivered the alpha magnetic spectrometer to the station, where it was installed robotically on the S3 truss you can see over there on the left of this graphic. Much of the work so far has been removing some of the debris shields and cutting some of the necessary tubes that will be ready to accept this configuration, the UTTPS. You'll hear that a lot during today's spacewalk. That is really just the new pump system. A lot of work has been done to get this pump ready. All of the necessary components are on the inside of the box. The box just allows the thermal tracking and the new pump system to be installed neatly into the alpha magnetic spectrometer. A lot of work from the ground to configure some of the pipes and route them to the necessary locations to do what the AMS repair project manager Terry Yoakum describes as making it EVA-able. You see a lot of the components on the outside are simplified as Luca Parmitano and Andrew Morgan will be working in their spacesuits with bulky gloves. And a lot of work has been done to make this box what it is, making it relatively easy for the spacewalkers to insert it into the proper part of the alpha magnetic spectrometer. Now you can see some of the components that they'll be working with in this graphic right here. Some of the components on the forward-facing part of this box they'll be working with up front. Those are some of the power and data cables that have already been routed on this previous spacewalks to the right locations. Once the box has been inserted into the alpha magnetic spectrometer, the spacewalkers will route those cables to the necessary connections and mate them to allow data and power to be routed to the new pump system. Flight controllers in Mission Control Houston will power up the box, checking it out, making sure everything is working. And then you can see those AAFs at the top. That's the AMS alternate fitting. This AAF is a critical part of today's spacewalk. Will take up the majority of the time for the two spacewalkers, but really allows some of the tubes that are fitted on the new pump system to be easily fitted with the tubes that have already been cut on the previous spacewalk. You can see the tube at the end is a little bit larger than the tubes that are routing the carbon dioxide through the current system. That allow the spacewalkers, Luca Parmitano to be exact, to insert those tubes into the fitting after straightening them out with some of the tools that have, again, been specially designed for this spacewalk. Here's the tools that they'll be using throughout the duration of today's spacewalk. Again, it'll be Andrew Morgan that'll be holding on to the tool board you see over to the left. It's very critical that these tools are well organized and accessible to Luca Parmitano, who will be the primary user of these tools. Of course, the pistol grip tool will be used as well. This is a common tool. It's the space drill that's used on many spacewalks, but these tools on the tool board have been specifically designed for the alpha magnetic spectrometer. You can see the large, what looks like a bolt cutter off to the left. That's the rough cutter that has been used on the previous spacewalk to cut most of the tubes. All 8 of them have been rough cut. And 6 of them are on the top-facing side, the zenith side of the alpha magnetic spectrometer. The remaining 2 on the nadir, or the earth-facing side of the alpha magnetic spectrometer. For most of today's spacewalk, they'll be using the tools you see over on the right. The clean cutter is a tool that's been specifically designed almost like a PVC pipe cutter, but a little bit easier to handle, as it's specifically designed to be used with bulky gloves in the harsh environment of space. You can see on the far right, that's where the tube will be inserted, and then what looks like a knob that you would find on your shower can be turned, and the tubes themselves will be cut cleanly on all parts of the tube for a nice round cut to allow it to be inserted into that alternate fitting that we talked about earlier. Now, the alternate fitting has to be measured to a very precise point for the proper swaging to take place. So the tube straightener will be used to not only straighten the tubes and allow them to be fit neatly into that alternate fitting, but to also measure exactly how far they'll be put into that alternate fitting and marked up with Kapton tape. Now, that combination wrench looks like a simple tool, but it's critical. It's a 7/8 inch wrench that will be used to actually do the swaging. Now, on that alternate fitting is neatly fitted for that combination wrench and can be used to turn just a little bit to allow the swaging. All that does is it just pinches those tubes and allows a nice seal between the alternate fitting to connect the tubes. It will hold the tubes together and allow carbon dioxide to flow freely through those tubes and complete the installation of that new pump system and allow the carbon dioxide to continue to cool the alpha magnetic spectrometer and carry it through the life of the station, collecting billions of particles and looking for the origins of the universe. Back to the inside of the International Space Station's Quest airlock, you can see Luca Parmitano already in the crew lock section. That's the far section. You can see a hatch in between where the Andrew Morgan is currently, assisted by Christina Cook off to the left and Jessica Meir off to the right. Way in the back there, you can see Luca Parmitano's head is facing towards the hatch. On his right side is that pistol crypt tool he'll use to actually bolt the new pump system into place inside the alpha magnetic spectrometer once he gets into position. It'll be Jessica Meir you see on the right of your screen that'll be controlling the robotic arm to grant him that access to the work site where he'll be installing that new box. Andrew Morgan being fit in to the crew lock. Now to the right of this view, to the left of Andrew Morgan, is that new pump system already in the crew lock. Now that new pump system is, there'll be a series of handoffs to allow it to work its way over to the position that Luca Parmitano can enter into the station's robotic arm. Andrew Morgan will hand off that new pump system, and Luca Parmitano will carry it to the work site. As Christina Cook and Jessica Meir assisted the spacewalking astronauts to get ready for today's spacewalk, we've talked about some of the tools and the main critical components of today's spacewalk that they'll be using. Let's go over some of the procedures that the two spacewalking astronauts will be going over this next spacewalk to complete the installation of the new pump system to the alpha magnetic spectrometer.
Luca Parmitano and Drew Morgan will once again be going out on AMS EVA. This will be EVA number 3 in the repair sequence. This is the EVA where the new AMS pump system will be brought out of the airlock and installed on AMS itself. The pump system is rather large and cannot be transported by a single crew member. Therefore, both crew work together handing off the pump system one to the other as they inchworm their way from the airlock all the way to the forward side of the external support platform number 2. The Canadarm2 or SSRMS will meet the crew there, at what point Drew will take control of the pump system while Luca ingresses the articulating portable foot restraint on the SSRMS. Once in the foot restraint, Luca will take the pump system and prepare for the flight of the Canadarm2 from ESP2 all the way over top of the truss to AMS, in a similar manner to the trajectories he's taken on EVAs 1 and 2. While he's riding the Canadarm2, Drew will translate hand over hand across the truss and up to ELC2 with bags to prepare the work site to meet Luca there for the installation of the pump system. Drew will provide eyes on to assist Luca in aligning the system and install it onto AMS into the mechanical attachment device. Once there, the crew will use the pistol grip tool, the PGT, to connect the bolts, as well as connecting the power and data cables, securing the new pump system to AMS and allowing the heaters to be activated. Once the system has been powered on, it'll be prepared for the fluid connections, which Luca will do from a different work site on AMS. The SSRMS will carry him from the zenith side to the aft side here, and he slides in to get ready for those fluid connections. There'll be 6 fluid connections completed here at this VSB work site using commercial off-the-shelf swages. Those swages have been encased in a custom fitting that the engineering teams have developed to allow the astronauts' pressurized gloves to operate the small ferrules of the swage. Once those 6 switches are completed, the SSRMS will take Luca to the underside of AMS for 2 final switches. Drew will have to pass the tubes from the new pump system down through a passageway in AMS to allow Luca to connect those on the nadir side here. While at that nadir worksite, Luca will have to be mindful of several hazards to AMS and tight clearances while he switches those tubes. Once complete with the 8 switches, this will allow the engineering teams to pressurize the system. And with the crew's work complete for the day, Luca will ride the SSRMS back to the forward side of VSP-2 and prepare for airlock ingress. While Luca's riding the arm, Drew will be translating back and starting to bring bags back inside that have been left out on the ELC over the course of the EVA series. And with both crew back at the airlock, that'll complete EVA 3 of the AMS repair.
This is Mission Control Houston. As you can see, the entire EVA, this entire spacewalk is about installing that new pump system and connecting the tubes. Now, all of the work done so far on the previous 2 spacewalks has been for really this moment. The first spacewalk being mostly about granting access. The access that you can see Andrew Morgan stationed by as Luca Parmitano was on the end of that robotic arm during that animation, installing handrails and removing debris shields that allowed them the necessary access to these work sites. And the second spacewalk was really about getting those tubes cut, the ones that they'll be swaging throughout the duration of today's spacewalk, and also installing the mechanical attachment device that the new pump system will be mounted to. They routed all the cables, and basically everything is in place to really get ready for the acceptance of this new pump system. Now, while it looked like it was relatively simple to actually install the box and just connect some cables, there's actually a lot of intricate work that's involved in this particular spacewalk. You can see some of those tubes in the animation were capped off. So they were originally routed behind a vertical support beam. That beam was removed on the first spacewalk to allow access to the tubes, and then they were cut inside that workspace on the second spacewalk. They were pulled out and capped off and marked so that the astronauts knew which tubes were which. And now they'll know where to install them and which fitting to use for each of the tubes and where they connect to make sure that the new pump system is running smoothly once they actually get it installed. But that intricate work, they were rough cut. Really the clean cutting will be a significant portion of that. It will take some precise work, much of it done by the tool itself to allow it to be most easily used by Luca Parmitano when he clean cuts it and removes the caps. That'll allow it to be physically mated by the alternate fitting. Swaged, basically that's just taking that wrench and cranking a bolt that's inside of that alternate fitting to sort of pinch the tube and allow it to be nice and mated so that the tubes connect and that carbon dioxide can easily flow. There is that new pump system, the UTTPS, in the hands of Jessica Meir, as Christina Cook getting some of the final work done in the crew lock. Jessica Meir bringing that critical box, the one that's truly the purpose of all of the work that's been done so far for the Alpha Magnetic Spectrometer, has really been for the acceptance of this box. Now again, that box will be fit over to the right from this view to the left of Andrew Morgan. Luca Parmitano will be the first out the hatch, and it'll be up to Andrew Morgan to hand off that pump system to Luca Parmitano on the outside of the hatch, and they'll make their way over to the external platform to allow Luca Parmitano to enter into the Canadarm2, the station's robotic arm, with the new pump system in tow, riding it, taking almost the elevator ride to the alpha magnetic spectrometer, as Andrew Morgan takes the stairs and has to take the crew lock bag and all of the equipment and tools that are still inside the airlock and bring them over to the worksite. Jessica Meir will be the ones at the robotic arms controls, maneuvering Luca Parmitano into the correct positions. Now, of course, the astronauts you see in this view are not alone. They'll be much of the work will be done here in Mission Control Houston. Teams here are from the Orbit 2 team that recently handed off and will be overseeing the spacewalk through the duration today. Teams here in the room are led by Flight Director Emily Nelson. Emily Nelson will be leading the teams all throughout Mission Control Houston today. To her right, you can see astronaut Ricky Arnold. He'll be the Capcom. You'll hear his voice through some of the procedures through the suit up activity today before they actually, or before they egress or exit the hatch to begin today's spacewalk. From there, Jeremy Hansen, the ground IV. He'll be the main communicator to the two spacewalking astronauts today, Luca Parmitano and Andrew Morgan. Hansen himself has spent a significant amount of time training for the alpha magnetic spectrometer spacewalks, using some of the tools themselves, and be able to guide the two astronauts through their procedures today. Christina Cook and Jessica Meir, of course, on board, overseeing some of the suit-up activities, led by Christina Cook. Jessica Meir will be the lead for the robotic arm that'll be used throughout the duration of today's spacewalk. Of course, Emily Nelson leading the teams, but not alone here on the ground. They have the help of Jeremy Hansen, who has the expertise of the alpha magnetic spectrometer himself, and of course John Malarski, who's leading a large team of spacewalking teams are here in the back rooms, but he is the lead spacewalk officer here in Mission Control Houston. Understands the tasks of today's spacewalks as well as the remainder of the alpha magnetic spectrometer spacewalks. 4 years of work into the procedures today. A lot of work in developing the tools and going over some of the intricate procedures to make sure that it is a successful installation of the new pump system. You'll hear the voice of Jeremy Hansen from here in Mission Control Houston, again throughout the duration of today's spacewalk. The teams here leading the spacewalkers through their procedures, and of course, with the help of their crew members on board the International Space Station, primarily Jessica Meir at the hands of the robotic arm. Back on the International Space Station, again, Christina Cook to the left, Jessica Meir to the right, overseeing some of the procedures to get the two spacewalking astronauts ready for their procedures today. That new pump system you see off to the right in the crew lock, in position. The following procedures will be Christina Cook and Jessica Meir closing the hatch and getting ready to depressurize the crew lock where the two spacewalking astronauts are right now. The official start time of today's spacewalk will be after depressurization has been complete. The two spacewalking astronauts will switch to battery power. That marks the official start of a U.S. spacewalk. Now, some of the procedures that we went over today to install that new pump system and fit the tubes that have been already cut to the alternate fittings and get them connected to that new pump system. It's a lot of intricate work. If you have any questions throughout the duration of today's spacewalk, please use the hashtag AskNASA on your favorite social media platform. We'll be following along and answering questions along the way as the two spacewalking astronauts, EV-1 Luca Parmitano and EV-2 Andrew Morgan, work their way through the procedures to install the new cooling pump system to the Alpha magnetic spectrometer. Jessica Meir closing the hatch between the equipment lock of the Quest airlock and the crew lock. On the other side of that hatch, Luca Parmitano and Andrew Morgan getting ready for the start of their spacewalk. Next thing you'll be hearing is Christina Cook now communicating with the crew on the other side of the hatch. You'll hear her voice as she guides the two spacewalking astronauts through the procedures for depressurization of the crew lock.
Airlock on 1, step 70 and 71 are complete. Looking for your go to step into 72 when we have 100 minutes. I'm showing in 30 seconds.
Airlock Houston, you have a go, and 72.1, 70.2.2 are complete.
Copy that, Ricky. Great to be chatting with you. Hey, Drew. We are now hot mic'd with Houston, and we're proceeding on with the depress. First of all, please check that the depress pump power is off. The depress pump enable LED is on. And Houston, with your go, we'll proceed to the depress cue card.
Airlock Houston on 1. We'd like you to hold here for a moment. We're still finishing up 72.3.
Copy, you're finishing 72.3.
Again, Christina Cook on the inside of the equipment lock of the Quest airlock. She's holding the communication device there and communicating with the ground. That voice you're hearing from here in Mission Control Houston is the Capcom for today, Ricky Arnold. He'll be communicating with the crew on the inside of the International Space Station. You'll hear the voice of Jeremy Hansen, who will be the voice from Mission Control up to the two spacewalking astronauts. Right through their procedures as they exit the hatch and install that new cooling pump system onto the alpha magnetic spectrometer. What you're seeing now is the astronauts working through the procedures to depressurize the crew lock that's on the other side of the hatch. On the other side are the two spacewalking astronauts, Luca Parmitano, EV-1 lead spacewalker today from the European Space Agency, and Andrew Morgan from NASA, EV-2. Parmitano will be wearing the suit with red stripes.
Houston on 1, crew is hot mic, step 72 is complete, and you are go in step 76.
Copy that. Yep, good read. We did complete 74 and 75 in the meantime. Moving to the depress cue card. Okay, Drew, for you on the UIA, you can switch the depress pump power to on, ON.
Depress pump power on.
See, we're now going to wait 10 seconds. I'll give you the go to the next step when it happens.
It takes coordination by astronauts on both sides of the hatch to depressurize the airlock. It'll be depressurized in phases.
Now take the depress pump man ISO valve to open and expect an alert tone.
Depress pump man ISO valve open.
Copy, I see pressure decreasing. For both of you, you're going to monitor your suit P gauge that it stays less than 5.5. If it goes above 5.5, Drew, you'll stop the depress by closing the depress pump man ISO valve.
Okay.
Copy 13. Copy 12.
Losing some video communication from the International Space Station. You can still hear some of the audio, though. That'll happen throughout the duration of today's spacewalk as the video communications and audio are coming through communication satellites called TDRS. That's Tracking Data and Relay Satellites. They're geosynchronous satellites that provide the video and audio communication, now regaining some of it. You can hear that sound. That's depressurization that's underway right now.
Can you confirm that was 10.0?
That was 11.0.
11.0.
The station normally at 14.7 pounds per square inch PSI. That's about what you would find at sea level. You can hear the readings from the crew that they're looking at about 10 PSI now. They'll make their way down to 5 and do some leak checks to make sure that everything's okay before they proceed down to vacuum. Everything on track for today's spacewalk. The crew lock now less than 10 pounds per square inch. Losing some of that video and audio communication. Again, those tracking and data relay satellites will be in and out throughout the duration of today's spacewalk. Otherwise, pretty constant communications to make sure everything's okay through the procedures of today's spacewalk. You saw a little bit of the outside of the International Space Station. The vehicle itself flying 259 statute miles, now over the northwestern border of Iran. You're getting a live look at the inside of the International Space Station Flight Control Room. The Orbit 2 teams here, overseeing the systems aboard the International Space Station, led by Flight Director Emily Nelson, who will continue to lead these teams, as well as the teams leading the 2 spacewalking astronauts today. Emily Nelson there at the forward end of your screen. To her right, Ricky Arnold. You'll hear his voice through some of the procedures until they officially hand over to Jeremy Hansen, who's immediately to his right. Jeremy Hansen being the ground IV. He'll be the voice from here in Mission Control up to the 2 spacewalking astronauts. He himself has spent a significant amount of time training in spacesuits, doing some of the procedures here on the ground through the spacewalking activities that you'll see Luca Parmitano and Andrew Morgan go through today, understand some of the intricacies of using the tools and angles, and will be guiding the astronauts through some of those procedures as he has the help of some of the flight controllers here in the room today. Spacewalking officer here in the room, John Malarski, leading the teams through the procedures of today's spacewalk, has the support of many team members in the back rooms who also have been working tirelessly for 4 years, putting these procedures together to make sure the execution of installing the new pump system to the alpha magnetic spectrometer goes seamlessly today. The work so far, getting the work site prepared, cutting the tubes and routing cables, everything pretty much set for accepting the new pump system today. Meanwhile, the crew lock continuing to depressurize. About to pass 7 pounds per square inch. Again, we're going to 5 to do a hold and then conduct some leak checks before proceeding down to vacuum. The start of today's spacewalk will officially begin once the 2 spacewalking astronauts switch to battery power.
7.0.
Copy 7.0, and I concur. For your awareness, when you get to 6.0, you can expect an alert tone, and then when we get to 5.0, we'll be pausing the depress for a leak check.
Copy.
Still awaiting some video communication from those tracking and data relay satellites. You're continuing to look at a live view of the inside of the International Space Station Flight Control Room. The voices you're hearing, Christina Cook in the equipment lock of the Quest airlock. She's guiding the 2 spacewalking astronauts through the procedures of depressurization. On the other side, you're hearing the voice of Andrew Morgan. He's EV2 for today. He'll be working with EV1 Luca Parmitano through the procedures of today's spacewalk. Now, this is, of course, not the first time the 2 spacewalking astronauts are going out the hatch. Both veteran spacewalkers, Luca Parmitano, again, EV1. He'll be wearing the suit with the red stripes. He's the space station commander for Expedition 61 right now. Has conducted 4 spacewalks in his career, 2 of the previous spacewalks, of course, being the alpha magnetic spectrometer spacewalks. His total career spacewalking time, 20 hours and 51 minutes. Andrew Morgan will be EV2. He'll be wearing the suit with no stripes, and his primary job throughout the duration of today's spacewalk will be making sure the tools are in order and assisting Luca Parmitano through the delicate procedures of installing the new box and connecting some of the tubes. This will be his sixth spacewalk. He's conducted 5 so far. Of course, the previous 2 being the Alpha Magnetic Spectrometer spacewalks. His total 33 hours, 30 minutes. This is the 224th spacewalk in support of space station assembly, maintenance, and upgrades. Meanwhile, the airlock continuing to depressurize. Now nearing 5 pounds per square inch. The next status you'll hear is a hold at 5 pounds per square inch, just to make sure there are no leaks before proceeding down to vacuum and getting through those final steps before officially beginning today's spacewalk once the 2 spacewalking astronauts switch to battery power.
So it's just showing 5.3.
Copy, I'm showing the same. And Drew, we're actually showing 5.0 on our telemetry right now. So with that, I'll have you take the depress pump man ISO valve closed.
Depress pump man ISO valve closed.
Copy. For both of you, switch your display status until you see leak check question mark displayed, then a long yes, and follow displayed instructions.
V1 copy. Q copy.
And we'll take reports of your present O2 actuator position and time left as you go.
Copy.
Depressurization currently paused for a normal leak check at 5 pounds per square inch. Just making sure that everything's okay before proceeding down to vacuum. Again, Luca Parmitano and Andrew Morgan in the crew lock right now, getting ready to begin their spacewalk.
Complete for EV2. And O2 actuator EVA. EV1 complete and stepping to EVA. I will report when complete.
See all, you're both complete with the leak check and you're currently actuating your O2 actuators into EVA.
This is Mission Control Houston. Again, you're getting a live view of the inside of the International Space Station Flight Control Room. Undergoing another handover of video communications. Should be regaining them shortly. You're hearing the crew work through the procedures to
Back to open.
Press pump man ISO valve open.
And I am taking the emergency MPUF to open. Again, monitor your suit pressure gauge. Make sure it stays below 5.5, and we'll pause the depress if you see it above.
Copy.
So that hold at 5 pounds per square inch is complete. Leak checks complete. Everything looking good to proceed down to vacuum. The crew lock now about 4.5 psi.
For your awareness, it does look like you have about a foot to 10 inches more of port movement on that U2TPS available. And there, yep, now it is fully port. So for your awareness, guys, it does look like you'll be heading out in a night pass.
Copy.
Copy 4.
The crew lock passing 4 pounds per square inch on the way down to vacuum. They'll switch the valve to close at about 2 psi and then proceed to vacuum from there. You just heard Christina Cook mention to the crew they'll be exiting the hatch during a night pass. The International Space Station crossing the Terminator line right now, 263 statute miles over the northern border of Mongolia into an orbital nighttime.
Copy 3.0.
About 2.1.
Copy.
This is Mission Control Houston, continuing the depressurization process. They'll switch the valve to closed at 2 pounds per square inch. You'll hear that call soon.
Copy. We're showing the same out here. With that, you can take the depress pump man ISO valve closed.
Depress pump man ISO valve closed.
And you can switch the depress pump power to off, OFS.
Press pump power off.
Copy. We are now ready for you to report your initial tether config.
All right. I'll take it from here. I will start from Drew's right-hand side waist tether. It's locked black on black on the airlock viewing extender. Small hook is on his viewing extender. It's locked black on black. And then he has a red small hook locked black on black on the right-hand side viewing extender, which goes to the reel. The red reel is unlocked. And the anchor hook of the red reel, which is yellow, goes onto the green reel. It's locked black on black onto the green wheel.
This is Mission Control Houston. You're hearing Luca Parmitano inside the crew lock right now, reporting his tether configuration. This is the cables that will keep him attached to the International Space Station, making sure that that configuration is good, that nothing's tangled, that everything is set the way that it's meant to be before they exit the hatch and continue with today's procedures.
Small hook is locked black on black on my right hand side waist tether and viewing extender. On my left viewing extender, okay, there. Okay, one, two, I have two small hooks. They're green. They're both locked black on black. And they go to two reels, which are both unlocked. The anchor hooks are on my middle workstation, and they are unlocked.
Luca, I copy all. We'll wait for Houston to also copy.
Houston copies.
Okay, if that's a good tether config for Houston, sounds like it is. Next thing for you guys is just to expect an alert tone when the DPDT starts to near zero, and after that we'll be looking at the EV hatch Delta P. I'm currently showing about 1.5 PSI.
Everyone copy.
This is Mission Control Houston. You're hearing a good tether configuration from the crew. Everything's looking good for the crew to exit the hatch. Just about on time, and go through their procedures for installing that new cooling pump into the alpha magnetic spectrometer today. Christina Cook in the equipment lock of the Quest airlock. She's on the inside of the International Space Station guiding the two spacewalking astronauts through the procedures of depressurization today. She'll soon be handing it off to Jeremy Hansen, who's the ground IV. Here in Mission Control Houston, you're getting a live view of the room now. Jeremy Hansen, Canadian Space Agency astronaut, has spent a significant amount of time working through the procedures himself here on the ground for what the crew will be doing today to clean cut some of the tubes and install that new pump system. Jeremy Hansen will be the one here at Mission Control Houston. You'll hear his voice up to the spacewalking astronauts to carry them through the procedures of today's spacewalk.
You got this thing fully ported. Yeah, I'm just trying to find a position. I'm going to have two positions, one for opening the hatch and one for unlatching, and then one for opening.
Tell me what you need me to do. I think we've got all we can on the UCTBS, so the only thing that could move maybe would be me.
I think you'll be fine, Drew.
Okay.
It's going to have to be me kind of my side space for my legs. One thing that I may ask you is to rotate, maybe.
Yeah.
Something like that, but that's later, after I latch.
Okay.
And I have a lot of parallax, but I think we are close to 0.7, 0.8, something like that.
Okay, copy. You're seeing about 0.7, 0.8 on the EV hatch pressure gauge. I'm currently showing about 1.0.
Okay, good to know.
And we are waiting for that 0.5 till we give you the go to open the hatch.
Understood.
This is Mission Control Houston, still working through the depressurization. Now a little bit less than 1 pound per square inch inside the crew lock. The goal now is 0.5 psi. Once we get there, the crew will be given a go to open up the hatch. The spacewalk itself will officially begin once the two spacewalking astronauts switch their suits to battery power.
Christine, I see 0.5 from here on the 0.5 SID on the gauge on the hatch. What you got?
After that, Luca, I have 0.8. Let's check in with Houston. And Houston, airlock on 1. I'm showing 0.8. Luca's got 0.5. Let us know if we have to go to open and stow the EV hatch.
Airlock Houston, your go.
RPM go. Whatever you need. Right now, let's try and first unlatch it. Okay, fully unlatched. Now I'm going to go up and back.
I got the expected suit P message.
I need more space.
Okay. I am
Have your message.
far port as I can. You got it, buddy.
All right.
Nice job.
All right, that's done.
Luca, I copy the EV hatch is opened and stowed. I see that. Looks like the thermal cover also went open.
Yeah.
With that, I am closing the emergency MPEV. And that completes our depress. With that, I'll turn you over to Ricky. Drew, Luca, it's been great working with you this morning. We're looking forward to watching your EVA.
And Christina, as always, you were awesome. Thank you both, and Jessica for the support.
Just perfect. Everything's perfect.
All right. Good morning, gentlemen. Jeremy here with you. All right, we're going to get going. Thanks, Nana and Jessica, for the great work this morning. So for both Drew and Luca, you can switch power to battery. Let's stagger the switch throws. Expect a warning tone. Then check display switch functional.
EV1, switch to battery. EV1 is in battery.
Hey, EV2 battery.
And my display was, oh, it's good. Oof.
Okay, Drew. As I assume your display switch is functional. On the UIA, you can switch power EV1 and 2 to off and check the 4 LEDs are off.
Copy. The UIA EV1 power is off and LEDs out, and power EV2 off. Volts are 0.
Luca, you can, or both of you can disconnect your SCU from your DCM, close the cover, and stow it in the pouch.
Copy.
It worked.
And you just heard a good switch of the suits to battery powered by both Parmitano and Morgan. The start time for today's spacewalk, 5:31 a.m. Central Time. The International Space Station was 261 statute miles over the Pacific Ocean just east off the coast of Japan.
Okay, Drew, check the depress pump manual isolation valve is closed.
Depress pump manual ISO valve is closed.
Okay, on your DCM, take your temperature control valves to max hot.
Copy, max hot. EV1, max hot.
EV2 max hot.
Okay, switch water on.
EV1, water on.
EV2 water on.
Check DCM blank, bite off.
DCM is blank, right off.
And my DCM is blank and the bite is off.
Okay, temperature control valves as desired now, and then check your SUP gauge and report to Houston.
Copy.
Okay, for Houston, I got the TCD is at 4, and I have 4.2 on the gauge, SUP gauge.
And for EV2, my SUP gauge is 4.3, and my TCB is set to 4.
Okay, you're aware that we're going out into nighttime, so visors as desired. We got the SUP parameters on the ground, so you guys are go to egress. Luca, you can grab crew lock bag 4, take it with you, keep a large small ret. And good work getting that hatch open. Sounds like it's a tight fit in there for you guys. So out slowly, and let's take good care of the pump box.
All right, I'm directing to the back so I can get to it.
The voice you're hearing, Jeremy Hansen, the ground IV here in Mission Control Houston, guiding the two spacewalking astronauts through their procedures. From this view here on the outside of the International Space Station, you can see the thermal hatch sort of at the top right of your screen. It's that sort of fabric white circle. Just underneath that, you'll see Luca Parmitano be the first one out the hatch today. Spacewalk already officially underway. 5:31 a.m. Central Time was the time that the two spacewalking astronauts switched to battery power. You can see the first views of Luca Parmitano out the hatch. His bag first.
So, Luca, as you get outside, you're going to throw down your safety tether, then Drew's, and your temp stowing crew lock bag 4.
Roger that. Okay, my safety tether is locked black on black on that forward viewing.
Copy, Luca.
I need Drew's. Okay, Drew's safety tether is locked black on the aft unit, the viewing outside. It's locked black on black. Drew, you're safe to release your tether.
Okay, copy. I'm safe outside, and I can release my right brace tether.
I'm going to go attempt to stow his bag.
Okay, and we had a plan for the aft airlock handrail, Luca. Next, you'll be working on your fare leads. And just let me know if you want me to call them out. I know you got a plan for that.
We do have a plan. We're putting into fact into right now. Drew, I put the bag on the closest airlock toolbox.
Perfect.
We're going to start doing my safety tether leading.
Sounds great.
And Sammy, would you mind reading me all the numbers of the expected?
Yeah, so you're going to start with the handrail right near the airlock. It's 554, right near the hatch. And then you're going to go basically to the radio handrail. It's the 4 o'clock position. That's 504. And next to it is on the circumference, or right on the edge of the wagon wheel, is 503.
So you can see Luca Parmitano outside the hatch right now. He's just doing his tether configuration, leading over to the work site that he'll eventually ingress or enter into the foot restraint of the Canadarm2, just making sure that that's all set. The next step will be for Andrew Morgan to hand off that new pump system. Luca Parmitano just getting some of that tether work done ahead of time, as he'll have to handle the large box containing the new pump.
All right, Luca, we can't get on ESP2 until we stop exercise inside, and we just don't have that confirmation yet. We're working it. So just do the 3 on the airlock and then stand by 1. Drew, you can start slowly wiggling the box towards the hatch.
Yep, I'm wiggled into a good position.
We'll have this squared away here in a moment, Luca, and we'll be back on track.
Oh, good. We're working anyway.
Luca, are you putting down a Richmond's fare lead on one of these handrails?
Depends on how the tension goes. If there isn't a tension, then I don't need it. I'll keep it on me.
Okay. We still are.
And if I do, it will be on. If I do, it will be on the ESP.
Okay, understood. So we're not clear on the ESP2 yet, but let's just talk about it. So the one over there is 8024, and it's kind of like on the bottom part, the nadir part of the closest connection of ESP2.
So again, Luca Parmitano working on configuring his tethers, hooking them to the right handrails and getting ready to receive that box. That'll be coming out the hatch. You see the thermal cover, the sort of fabric flap that's sticking out. That's where the crew will be exiting. Andrew Morgan still inside of the crew lock, but with the new pump system in hand, we'll be handing it off to Luca Parmitano.
On the airlock, missing number 3, which was 502 or 503?
503. It's right on the wagon wheel. Basically, 504 points straight at it, almost straight at it.
Got it.
As Parmitano is working on some of those handrails and connecting his tethers.
On the ESP, and you wanted me on 802.
Yeah, you're going ESP2, and what was the last thing you said?
802.
Oh, yeah, 8024 is the one in ESP2, 8024, and it's basically nadir handrail, most nadir handrail.
As Parmitano works through some of the handrails and connecting his tethers, again, we're waiting for Morgan to send out the new box once everything is configured. There's some complicated procedures coming up to install that new pump and connect and swage some of the tubes that route some of the cooling air to help the alpha magnetic spectrometer to function and collect billions of cosmic particles. We'll be answering questions using the hashtag AskNASA throughout the duration of today's spacewalk. We have one from Kostov, who asks, how often does the station's cosmic particle detector need to be repaired? A great question. This particle detector was actually never designed to be repaired on orbit. It took a very smart and integrated team of scientists and developers of the alpha magnetic spectrometer, as well as spacewalking experts, to come up with the right procedures, the right tools, and the right techniques to repair this cosmic experiment. This will be the first time, but the new pump system is designed to carry the alpha magnetic spectrometer through the life of station and continuing to collect billions of particles.
Drew, Christina with you on Space to Ground 1. Wanted to make you aware, it does look like Luca's SCU may have caused some of the tabs to lift on the MLI on the radiator side. Good. Yep, that's perfect.
Yes, I see it. Yep, on the mud flap. Recall.
Okay, I see you correcting that now. Good job.
Yep, and I'll just ask Luca to pat on the other side of the mud flap. Yep, a little SCU.
Hi, Drew. I'm in a position.
So, Luca, before I give it to you for a handoff, you're able to put a hand on the mud top closest to you. It was elevated a little bit, trying to contact the SCU.
Yeah, it's all flat now.
All flat, okay.
Yeah, it's all good.
All right, the thermal cover seems to be coming our way. There we go. All right, so it looks like I'm in the hatch, and I'm going to rotate the side with all the connectors on toward you. If you could just ensure that my tether sides, I think it's maybe best if I pull it my way. I see you got the corner.
Yeah, I got a red on it.
You have a red on it.
Yeah, let me put down a local for myself.
Yeah, go ahead. I'm going to remove my red because you have a red on it.
You can remove your red.
Okay, my red is released. The red is to you.
You're hearing the two spacewalking astronauts, Andrew Morgan and Luca Parmitano, talk to each other, making sure that their RET, their retractable equipment tether, that they're attaching their cables to the equipment, to the new pump system.
Which direction should we go?
Clock it. I counterclockwise.
You're counterclockwise, so my clockwise.
More perpendicular. There's that one of the flaps is at AES I get things off currently.
Okay. On the hatch edge?
Yeah, okay, now it's good. Now it's clear.
Good, clear.
Now
okay.
it's clear.
All right, I'm going straight down.
Yeah, go straight down.
You feel good about your position there? If you need me to hang on to it a little bit longer?
No, I'm good. I'm good. Keep going. Keep going. Going.
Okay. And let me know when you have complete control.
Okay, I have the pump. I don't know if I have a good position to rotate it.
Okay, so I'm going to keep a hand on it.
Yeah.
If you want to readjust, I still have control of the pump. And
Okay,
you have
control.
I have control of the pump.
I have the red.
Keep an eye on the red.
The red is good. Okay, I have the pump.
Okay, are you up on the toolboxes?
I am.
Perfect. All right, you have the pump.
I have the pump.
All right, your pump.
My pump.
Parmitano confirming he has control of the new pump system, taking it out of the airlock.
Luca's SCU pouch.
Still inside is Andrew Morgan. Now that the handoff to Parmitano is complete, it allows Morgan to exit the hatch. They're going to do something called inchworm over to the next work site. They'll take the pump over together. Again, Parmitano already set up his tethers to that new work site. But over there, Luca Parmitano will enter the foot restraint that's on the end of the station's robotic arm, which will carry him over to the worksite of the Alpha Magnetic Spectrometer with the new pump in tow. But they need to work together to get it out there first. Just working through the procedures to make sure they're taking that new pump and both going to inchworm it or maneuver the new pump system over to that work site so that Parmitano can get into the robotic arm.
Go down here. Comfortable?
All right, let's take it easy. So, I see your helmet cam is on. You want to turn your GoPro? All right. 1, 2. I need to pitch up a little bit. It's covered by your safety cutter. Okay, 3 times up, and 1. And the handle is down, and the second handle to your right, if you can keep rotating a little bit, and the other handle is down. Okay? Good.
Copy. I see you have green light. See 3 taps. If I could have your right hip toward me. 3 taps up, and your handles are both down. Half is dry. I've got a good baseline look at my gloves. They're in pristine. I'm just gonna bring your BRT up a little bit here for you, out of the way.
Yeah.
Okay, it's tucked in. All right.
Okay.
Let me take a look at the safety tethers behind us.
Yeah, my hand is dry. I cannot get a look at my gloves right now.
Yeah, no problem. We'll bring a hand off in a second. I see the crew light bag and our safety tethers. Okay, I think we're in a good config. Let me see if I'm going to rotate on here and close the thermal cover so that it is complete.
Okay, and the only thing we're missing is making sure your reels are unlocked for both of you.
Stand by. Okay. Reels unlocked. Reels are unlocked. Let me check yours. Locked.
Okay.
All right, so now we're going to put my rep on it.
Yeah, that's the best thing you can do right now.
Okay, my red is on it. Take your red off of it.
Yeah, you can just leave it hanging. And tell me when you have a good chance.
Okay.
Just put a hand on it.
Okay, let's get it stable.
Alright, I still have a hand on it. Stabilize, find yourself a good position.
Okay, guys, something that's worth thinking about is the sun is going to be coming up in the next few minutes here. So getting yourself in a config where you'll be able to grab your visor and the pump.
Okay, thanks. That's good to know.
I think I'll be good. All right.
You're good right now?
I have the pump.
Okay, you have the pump. I'm releasing the pump in my hand. And I'm going to go on to speed 2.
And we have it radiator outboard.
Okay, those are good words, Drew.
Again, the two spacewalking astronauts, Luca Parmitano and Andrew Morgan, working to carry that new pump over to the new work site That work site being where Luca Parmitano will ingress or enter into the foot restraint of the station's robotic arm. Less than 2 minutes until sunrise now, still in an orbital nighttime.
Okay, Drew. Let's see if you can. I'm gonna put my red on it.
Copy.
I have a red and I have the pump.
Okay, I see you have the ret on the scoop there, and I'm taking my ret off.
Yeah, you're cleared.
Okay.
I have the pump, I have control.
Okay. That's the pump. And if it's stable, we got plenty of reach there on the corner.
Yeah. So good. You can come onto your speed.
Copy.
Again, working to maneuver that new pump over to the Canadarm2. The rets they're talking about, that's a tether to make sure that the new pump is attached to them at all times. The scoop is a handling aid and allows the equipment tether to be easily attached to the pump. Allows the handling of the new pump over to the worksite a little bit easier. They won't have to carry it all the way to the alpha magnetic spectrometer, though. Parmitano will have it in hand as the Canadarm2 takes him over to the worksite. Sunrise happening now over the South Pacific Ocean, International Space Station 267 statute miles.
Drew, when you're in a good position, do your visor. And then, once you do your visor, I'll hand it off to you.
Another handover in video communications. You're getting a look at the inside of the International Space Station flight control room. Teams here led by Flight Director Emily Nelson. The voice you're hearing to the crew, currently maneuvering the new pump over to the Canadarm2, where Luca Parmitano will carry it to the alpha magnetic spectrometer. That's the voice of Jeremy Hansen. John Malarski, the spacewalk officer today, leading some of the tasks and guiding the teams here in Mission Control Houston with the support of his team in the back rooms through the intricate procedures that have been designed over the course of 4 years.
I'm going to take it from this side. Okay.
You have the pump?
Stand by.
Okay.
I have the pump.
You have the pump. I'm releasing my hand and lowering my visor. Okay, also glove check. 1, 2, the gloves are pristine. This becomes my better. I'm going to try to get all the way that side.
Good.
Okay, so good?
Yep. Now, you have a good view of the AS, just make sure everything is still tucked and looks like it is.
I don't have a good view of from here, but
Okay.
I have the pump, I have control.
You got the pump, and you have control. control.
I have the pump, I have control.
Copy. Okay. I might that'll meet you all the way at that corner.
Yeah, what's up for the pump?
You pulling closer to you.
Right here.
All right, I'll stop here at the pin here. We'll do one more move. Okay. All right, I have the local down. I have the pump. I have control.
You have the pump, you have control. Okay. Here, see the arm. Okay, Judy is gonna be the last pass.
Okay.
I'm gonna go beyond the APFR here.
Yep.
Okay.
Where do you think I should BRT?
You can BRT here on one of these. Right on the starboard of the APSR.
That looks good.
You know what I'm saying?
Yep.
It's a good hold right here. Okay, Drew. You can push it. I have the pump.
Okay.
Stand by.
I'm holding. I still have it.
28 minutes into today's spacewalk, you can see the two spacewalking astronauts maneuvering that new pump system
Ready for it?
Yep.
over to the end of the Canadarm2. Already inside is a foot restraint that Luca Parmitano, the EV1 for today's spacewalk. He's wearing the suit with the red stripes. He'll be entering into the foot restraint. Morgan will handle the new pump system until Luca Parmitano is fully ingressed or entered into the foot restraint. He'll hand that pump system off to Parmitano, and Parmitano will take it with him as he rides over to the work site of the Alpha Magnetic Spectrometer.
Okay.
You have control?
So just before I hand off to you,
Yeah.
I think once you get ingress, I think we've got the reach without any further GCA, I think.
I think so too.
Okay, I have control. I
You
have a
have
red on it.
control and you have a red. Now, me, see my red? Okay. And now I'm going to be talking to Jessica for the arm configuration.
Luca, brakes are on. You have a go for the APFR config.
Copy. Okay, it's going to be touch translation down.
So, Luca, you can read all the settings on the APFR for us as you come along and pitch the width extender to 6 alpha 7.
Okay, it's going to be in work.
Luca, if you need a better position for config, a reminder that we will be going starboard and nadir. We can do any of that motion or GCA that you required earlier.
No, actually, right now it's so good. I might be able to do everything from this position. it may be the most convenient.
Parmitano working to go into the foot restraint now. You're hearing the voice of Jessica Meir from the inside of the International Space Station. She's at the controls of the station's robotic arm.
It'll be backwards. So currently,
Once Parmitano is situated inside the robotics arm's foot restraint, Meir will navigate Parmitano with the new pump system in tow over to the worksite at the Alpha Magnetic Spectrometer where the pump will be installed.
and then for the width, I have 7. And I'm going to currently at Golf. I'm going to Alpha. Is that correct?
Affirm, Luca. Those are all good numbers so far.
Yeah, I got Alpha. And the clocking of the width is also 6.
Okay, those are good
Ready
numbers.
to put
Yeah, it's time to do your tether swap onto the arm.
work. Okay, my arm, the safety tether is locked black on black on the arm. And I'm ready to navigate back up. That's all good. Andrew, it looks like I will need a little bit of GCA to be far away from here.
Yeah, I'm thinking maybe just go ahead and ingress and then come toward me.
I have to drop my
Yeah, absolutely.
tether first.
Yep. And it looks like you'll have plenty of reach to get somewhere.
Okay. I think this position here is a pretty good one to draw my safety with my...
Yeah.
Luca, I'll take that handrail number where you dropped your safety tether if you see it.
It's actually... I don't see it. It's on the frame.
Okay.
It's a hoop. It's right below wrist 6.
Okay, that works, Luca.
It's a hoop
Thanks.
on the frame. It's a temp store. It's very convenient.
Sounds good.
Okay, now I'm going to ingress the arm. That makes sense.
Okay, copy that, Luca. And would you like that manual maneuver first, or do you want to go where you are?
I think it's easier if I just go where I am and then you drive.
Okay, copy. Brakes are still on.
Okay. That's good, Luca. The only other thing I wanted to talk to you about before you pick up the box is glove and a hap check, and then we'll check your glove heaters and cooling.
Hey, Mr. Boshoff. I did a glove check during supposedly the LOS, and I have pristine gloves, and my hat is dry.
Okay, sounds good. Well played on the LOS glove check. It's clever. And the only other thing is lights.
Our lights are on.
I concur that my lights are both on.
This is Mission Control Houston. Parmitano still trying to navigate into the foot restraint. You can see him over on the right of your screen. He's wearing the suit with the red stripes.
Your VRT is trying to prevent me.
He'll be in the foot restraint of the Canadarm2 throughout most of today's spacewalk, as the Canadarm2 will provide him the necessary access to all of the intricate work sites of the alpha magnetic spectrometer. To the left of the screen, Andrew Morgan holding the new pump system. Once Parmitano is in place, he'll hand that pump system over to Parmitano, who will ride the Canadarm2 over to the work site to have it installed, taking sort of the express elevator route to the alpha magnetic spectrometer, while Andrew Morgan goes back into the airlock, grabs some tools, and takes the stairs over to the Starboard 3 work site. On the top are the zenith-facing, that's the space-facing side of the International Space Station.
Okay, Luke, I'm going to give you that starboard motion. You're going to be going about 1 meter station starboard.
Copy.
Motion.
That's good motion, good clearance from my perspective.
Concur, good motion.
All right, Luca, now I'm going to bring you station nadir about 1 meter.
Okay.
Starting motion.
That's good motion and good clearance.
Concur.
Jessica Meir at the controls of the station's robotic arm, maneuvering Parmitano, currently in the foot restraint. Background there, you can see the International Space Station 266 statute miles over the South Atlantic Ocean. What you're seeing is the east coast of Argentina.
You think you can lean forward to it?
Morgan now handing off the new pump system over to Parmitano.
You and VRT. Okay, Jessica. If you still have motion, I will take another half a meter starboard.
Okay, copy that, Luca. We'll give you another half a meter starboard.
I have a very good view of the arm, and everything is clear.
Okay, we copy. Starting motion.
Motion.
Clearance.
Continuing. Here's your half meter.
And it's a good position. Do you think you can lower it a little bit? Yeah, that's good. I have a red on it. You can release your red.
Okay, you have a red on it,
GCA complete, Jessica.
and you have a
You stay complete?
hand on
I have a hand on it. I have control.
You have control? My red is released. It's your pump.
It's my pump. I have control. I have a red. I have everything on it.
Okay, and if you want me to stand by to help any check on your looks like you're rotating it just fine.
Yeah, I want you to check the AAF from your side.
Roger.
Whenever you're ready. Yep.
Hey, they're looking good. I think the bundle is still attached, and 2 and 4 look to be tucked in like they were when we put it in. So, good.
A great view of Parmitano at the end of the station's robotic arm.
Yeah, the APFR is the biggest thing right now. And I see your tethers all look good. And I see the tether, your safety tether you're leaving behind looks good. So,
One of my foot is out.
okay, stand by. I'm going to get a hand on it.
I'm good.
Okay.
A great view of the pump system now next to the body of Parmitano. That new pump system, 350 pounds, about 159 kilograms.
Yeah, locked. Saturday.
Let me have a...
Yeah, I'm locked.
Okay, all right.
Okay, Drew, you're picking up crew lock bag 4 and heading out. Don't forget your Poorman's fair lead at the Cedar Spur. Luca, you're on your way.
Jessica, your go for your maneuvers.
Okay, stand by, Luca. We have a few things to configure here before we get moving again.
Copy.
All right, I'm on the move. Work site.
Shift the work site.
Parmitano set with the new pump in tow, awaiting for the next procedures for Jessica Meir to maneuver the arm to the work site. In the meantime, Morgan making his way back to the airlock. Inside will be a box of tools. First things first, they needed to move that new pump system over and work together to maneuver it over to that spot where it is now. Now, with some free hands, Morgan's going to make his way back to the airlock and grab some of the tools that are necessary to complete the work here at the Alpha Magnetic Spectrometer.
Data looks good. Met rates look good, so we're in good shape.
Excellent. Good to hear.
Your next job is don't let go of the box and enjoy the view.
Two things are mutually exclusive because the view is blocked by the box, but I think I'll hold on to the box.
Okay, that's a good call.
Again, Parmitano with that new box in his hands. Of course, he'll have the Earth right underneath him. Now the International Space Station, 262 statute miles over the South Atlantic, making a northeasterly trip. Should hit the western border of Africa just about 20 minutes or so. That new box, though, 350 pounds, 159 kilograms. Inside, the intricate work being done on the ground to make sure everything, all the connections would be easy, or at least as easy as possible for the two spacewalking astronauts. Some very fine parts that are difficult to work with gloves, but teams on the ground were able to design systems to be easily integratable with the Alpha Magnetic Spectrometer with minimal connections. The dimensions there, 42 inches by 32.25 inches by 16.25 inches. That's about 107 by 81 by 40 centimeters.
Good motion.
Copy, continuing.
And Parmitano on his way. His job is to essentially deliver that new pump to the Alpha Magnetic Spectrometer by way of the Canadarm2. Morgan's job will be to retrieve some of the tools from the crew lock, that's the airlock of the International Space Station, some of the critical tools that will be needed to install the pump. One of the tools in tow by Parmitano is the pistol grip tool he'll use to drive bolts to install that pump. But some of the finer tools, specially designed for the repair of the alpha magnetic spectrometer, being retrieved by Morgan now.
I'm trying to reel out a fair lead there. Like it's going to stay.
Luca, we're ready to start this first Joecast. It'll be 2 minutes.
Copy, 2 minutes Joecast.
Starting motion.
As Parmitano makes his way up to the work site of the alpha magnetic spectrometer, we'll be taking some questions using the hashtag AskNASA. This one from Timmy, who's asking, what is the device with the gold dishes on the space station? Right now, that's at the bottom, or the top left corner of your screen, just coming out of view now. Those are the solar arrays of the Cygnus cargo vehicle. That's the Cygnus CRS-12. That vehicle was the one that delivered the pump that you're seeing now in the hands of Luca Parmitano. Those are the Ultraflex solar arrays that are used while the Cygnus is in flight to the International Space Station. One of the many cargo vehicles that visit the International Space Station, delivering critical components like the one you're seeing right now in the hands of Luca Parmitano, and some of the tools and equipment that are used for the spacewalk itself. Parmitano undergoing some of the maneuvers by Jessica Meir. Jessica Meir at the hands of the robotic arm, maneuvering Luca Parmitano over to the work site.
Give us a moment while we load the next Joecast.
Copy, standing by.
Just off screen from this view is Luca Parmitano. At the end of the robotic arm, you can see the latching end effector of the robotic arm, essentially the hand. That gold structure off to the side, that's the articulating portable foot restraint, the APFR. You'll hear that acronym a few times. That's the foot restraint that's currently holding Luca Parmitano. Off in the distance, that's Andrew Morgan, with tools in tow on his way to the work site, the alpha magnetic spectrometer. From this view, you can see just off to the top there, that white structure on the very top of the truss, just before the solar rays that are pointing to the top right. 50 minutes into today's spacewalk. Everything on track so far.
We're ready for the next Joecast. This one's going to be 3.5 minutes.
Copy.
Starting motion.
As Parmitano makes his way to the Alpha Magnetic Spectrometer worksite, on the top right you see the external pallet delivered by the HTV-8. That's the H2 transfer vehicle, a Japanese cargo vehicle that delivered lithium-ion batteries earlier this year. That pallet still has 3 lithium-ion batteries attached to it. Some of the nickel-hydrogen batteries from one of the space station's power channels are already on that pallet. The rest will be installed next year.
And at the work site.
Okay, Drew. Crew log bag 4 is going down the ELC, and then you can set up the bags in the APFR.
In work.
Andrew Morgan reporting that he's already at the work site. Parmitano you see at the end of the station's robotic arm. He's carrying the highlighted component of today. That's that new pump that'll give the Alpha Magnetic Spectrometer the life it needs. That's a cooling pump, and will allow the Alpha Magnetic Spectrometer to continue to collect particles throughout the life of the station.
That's position hold. 1 moment while we load the next showcast.
Copy.
Jessica Meir working at the controls of the robotic arm, currently holding and waiting that next position. In the meantime, we'll continue to answer Ask NASA questions. Keep using the hashtag AskNASA to send them in. This question comes from David. David's asking, how does the Alpha Magnetic Spectrometer collect particles? A very good question. The key word there in Alpha Magnetic Spectrometer is magnetic. There's a very powerful magnet inside the Alpha Magnetic Spectrometer, significantly more powerful than the magnetic field of the Earth even. And what the magnet does is as cosmic rays and other cosmic particles pass through the Alpha Magnetic Spectrometer, the magnet allows those particles to spin in a certain direction, a certain speed, a certain diameter. And that spin can be calculated and measured inside the AMS as a data point, one of several billion. The Alpha Magnetic Spectrometer essentially gathering data with this magnet, measuring that spin and what kinds of particles. Depending on the direction of the spin and the mass of the particle itself, they can detect whether it's an electron or perhaps an antimatter like positron. Both of the same mass, but if they spin in different directions, it's a data point for...
No doubt, as are we. Did you make use of that adjustable out there for the fair lead as well?
A data point for more of the cosmic particles
As soon as I get the bag packed down.
that may reveal the origins of the universe. In the meantime, Parmitano is still making his way over to the Alpha Magnetic Spectrometer, the white structure you see sort of at the top of the truss there, just before the solar arrays. That's the S3 truss. That's where the Alpha Magnetic Spectrometer is housed. Morgan already there, getting his tool situated, getting ready for Parmitano, making sure everything's set for when he arrives. First thing to do would be to install that new pump system.
Position hold, Luca. We'll now load the next JoeCast.
Copy.
Fair lead is down. Large, small rets are on the bags.
From this view, you can see the feet of Andrew Morgan poking out near the work site. That's the alpha magnetic spectrometer. You can see AMS on the blanket there. He's working his tether configuration and making sure that he's all set up, since they'll be there for the entirety of today's spacewalk. Not too far behind Luca Parmitano, you can see making his way at the end of the station's robotic arm over to the alpha magnetic spectrometer. The new pump in tow. That'll be the first task once they get over to the alpha magnetic spectrometer, installing that box. Much of the prep work has already been done on a previous spacewalk. This prep work includes installing a mechanical attachment device. This is the device that will hold the new pump system, routing some of the cables that will be connected to the new pump system, and cutting some of the tubes that will be connected to the new pump system.
Starting motion.
And lead yacht 12.
Okay, copy that, Drew.
Stand by, Luca, starting in 5 seconds.
Copy. All right, motion.
Great communication by the crew aboard the International Space Station. Jessica Meir inside at the controls of the station's robotic arm.
At some point.
Hearing Jeremy Hansen, the ground IV. He's the voice here in Mission Control Houston to the spacewalking astronauts.
I reported that the bags were still here, then I just power cycled it.
Okay, thanks, Drew. And if you get a chance, check your mirror and see if you have a green light.
I got a green light now. Yeah, green light.
Thanks.
Parmitano continuing to make his way over. Once at the worksite, Parmitano from this angle will be positioned sort of upside down, his head pointing towards the Earth. Morgan, on the other hand, will be on the nadir side, on the bottom side of the alpha magnetic spectrometer, his head facing towards space. Parmitano's job will be to insert the new box into the mechanical attachment device that had been installed on the previous spacewalk. And it'll be Morgan's job to help guide Parmitano and the box into the mechanical attachment device. There's a soft dock and a bolt. That bolt fits perfectly with the mechanical attachment device and allows for a good alignment.
Position hold. We'll load the next JoeCast.
It sort of just holds the box in place to allow for the a stable position and allow for the data and power connections to be routed to the specified locations on the box. That'll be the next task once it's installed. Now getting a view from the helmet camera of Luca Parmitano. You can see some of the attachments for data and power from the view of Luca Parmitano's helmet camera.
All right, Luca, the next JoeCast will be 3.5 minutes.
Copy, ready.
Starting motion.
Okay, I put crew lock back 4 into under the fish strainer.
Okay. And that's in the green bag then?
Yeah, fish strainer and green bag.
Okay, copy.
That's true, red.
A little more than an hour into today's spacewalk, starting at 5:31 a.m. Central Time. Morgan already situated at the worksite. Parmitano almost there on his way currently. Again, he'll be positioned sort of upside down from this view to allow him access to install the box that's currently in tow, that 350-pound new pump system. Parmitano almost at the worksite to install that new box. Again, throughout today's broadcast, we'll be answering questions using the hashtag AskNASA. As Parmitano makes his way to the worksite, he's practiced this plenty of times on the ground. Michelle asks, what are the procedures for practicing the spacewalks, and how are the situations simulated in the interior of the space station?
And then we will be bringing you station nadir 2 meters. So Drew, that will be bringing him down toward AMS.
Okay, copy. So toward his head.
From.
Okay, Luca, we're already going to need a little bit of lean back. And Missy's just off to your left. And that's good lean right there, and you'll be able to see with that lean back, you'll be able to see that you're able to clear AMS. It is at about maybe half a meter. It's perfect. It's perfect. Let's do that.
Okay. I'm ready.
Okay, Drew and Luca, we're ready for motion.
Ready for motion.
All right, starting motion.
Morgan, from his angle, providing some insight.
Copy.
The view from Parmitano blocked by the 42 by 32 by 16 inch new pump. Still in constant communication with Jessica Meir at the controls of the Canadarm2. assisted by Christina Cook.
Okay, I would say stop motion here.
Motion.
Okay, so Luca, I would hold that right there. So we're really close to AMS, and so I think the next thing that we need to do is go toward DLC, toward your back, about a half meter. Right now you don't have the room to put the pump in front of you. We need to give you some more clearance.
So I can lean back more. So I would say let her drive to the position. Then we'll go to my right,
okay.
and I'll lean back, rather than drive the arm. I can lean back here. I can do this.
Okay.
And then I can split the pump.
Okay. Copy. And I'm going to move over to AMS then.
It'll be 40 centimeters to go to the published position.
And Jessica, I think I'll take those.
Okay, copy. And Drew, are you ready as well?
We're going to go continue 40 centimeters towards your head. Okay. All right, I'm ready for motion.
Starting motion.
Morgan providing that critical guidance.
Good motion, good clearance.
Working in tandem with Jessica Mira, the controls of the robotic arm, assisted by Cook inside the International Space Station, Parmitano at the end of the station's robotic arm. Right now, they're trying to get into a position to dock the new pump system to.
The big concern is just we're radiator to AMS right now, and I think you're going to need a little bit of back off. But did you want to accept this?
I think I will accept it, Jessica. I'll take 40 centimeters to my right.
Okay, copy. We need to get into the snapshot mode, so give us a minute, and then we'll get to that.
You have eyes on the map?
I do.
Okay. All right, you're going to feel me I'm going to be giving it gentle guides here, just to keep it from bumping into a handrail, but we're looking real good.
All right, thanks.
Showed up a lot quicker today.
Okay, Luca, we are ready. We're going to give you that 40 centimeters to your right, and Drew, the clearance for you will be Luca's right shoulder to the row.
Copy. Have a good view of it.
Okay, starting motion.
Okay, good motion.
Okay, good motion.
Good
So
clearance.
that's 20.
Preview.
That's 40.
And GCA complete.
Okay, copy. GCA complete.
Brakes
Would you like
on.
the brakes on now as well?
Yes, please.
Okay, stand by. Brakes are on.
I do. I'm going to lean back.
Right.
And then I'm going to teach the pump down. And then I'm going to need a little bit of guidance from
Yep.
you.
I'm going to put a hand on it.
Yep.
Just going to feel my tugs.
Yep.
Okay. All right.
As you're working that, guys,
over.
a reminder not to impart loads from both of you into either the AMS or the EOC at the same time.
Okay, copy.
Copy.
All right. Luca, come toward your right just a touch. Right? And then advance and X. Come back this way. Come back toward your head, and back away just a touch. You get a better hand on it. Okay. All right. Let's drive in a little bit. Okay. And you're over the stop dock. Give it a push. Okay. And hold that right there. In the stop dock, I'm just going to do some checks here. Here. Okay. All right, so the AAFs are clear of the docking envelope, and I can see 2 and 4. I think we should be able to pull it down past the vacuum case handrail there. Okay, yeah. All right, we're in soft dock, and I see everything is clear. Wires, cables look good on your end. Are you able to see around the cables?
I can't see the yes. Yeah,
Gentlemen, we're handing over here. We'll be back in about 40 seconds. You can get the PGT ready. Talk to you on the other side.
Okay.
Good work, Luke.
Good work to you too, bro. Hey.
All right.
Now experiencing a handover of some of that communication from the International Space Station. Video and audio should be regaining audio shortly. Might take a little bit longer for the video to regain. What you were seeing was Luca Parmitano at the end of the station's robotic arm. In tow, he brought the new pump system for the alpha magnetic spectrometer. This new pump system will be used for cooling the experiment, the cosmic particle collector on board the International Space Station. So far, this is the third spacewalk in a series of spacewalk designed for repairing this experiment, this box being the critical component of all the work that's been done so far.
Okay, that sounds good, guys. We're Bravo 7 clockwise 2 following the CAL on the PGT.
I'll be in work.
What you heard was Morgan and Parmitano working together to push that new system into place. It's been pushed into place, now working with Jeremy Hansen here in Mission Control Houston. That's the voice you're hearing from this room. He's helping the two astronauts through the next steps for programming that space drill, the pistol grip tool, that'll be used for securing the new box into place.
We were going to stage it on the Nader vacuum case handrail.
Okay, one more time. I have Bravo 7 clockwise 2.
Okay, good settings.
Correct.
And we're going to drive all 4 bolts, 4 turns initially, and give us a best effort on an accurate count for those first 4 turns in an X pattern.
Okay. Okay, study me bolt number 1. 1, 2, 3, 4.
Okay, copy.
And I have low torque right now. And the count, I don't have a count a rev here. No count, didn't count the rev.
Yeah, but I counted you at the 7/16, so I had you at 4.
Same here. Okay, good for number 4. Okay. 1, 2, 3, 4.
This is Mission Control Houston. You're hearing Luca Parmitano count the number of turns used by the space drill, making sure that that new box is secured to its position. Much of the work that follows will be making sure that the data and power cables are connected, and to use some of the fittings that are secured to the outside of the box. These are the AAFs. These are the alternate fittings used to connect the tubes that have been already cut on previous spacewalks.
1, 2, 3, 4 turns on 2.
Okay. And now,
Start again.
sounds good. We're going to final torque, and we're expecting an additional 4 to 6 turns.
Okay, I need to position it.
Just watch that contact on the handrail.
Okay. 1, 2, 3, 4, 5. Yeah, the side turns, but I still have a low torque. Try and get a green light.
Let's stand by. Let's see what they have to say.
Yep, no, I got a green light. Was less than a quarter of a turn, so a total of 5 1/4.
Okay. That's right in the window, 9 turns total.
And I read 23.9. 9 1/4.
Okay.
You're going for number 4.
And I see the black line is flush.
4 bolts total for Parmitano to drive. 3 have already been completed. Parmitano working on that last bolt.
1, 2, 3, 4, 5. 7.5. Green light. 25.5.
Okay. Copy that, Luca.
Going for number 3. Total 9.5. Look for number 3. 1, 2, 3, 4, 5. 5 1/4. Green light 25.3.
Looking good over here.
And number 2. 1, 2, 3, 4, 5. 5 turns and 1/4. Green light 25.6.
Okay. Those are all good, Luca. You can remove the scoop, hand it back to Drew. We're handing over here in about a minute. Drew, you're looking for the cap keepers next out of crew lock bag 4.
And all 4 lines look good as well.
Okay. Yeah, that seemed like a real clean install. Sounds good. Drew, that scoop, when you get it from Luca, is going in green bag fish stringer hook 1.
Okay. 1.
Talk to you on the other side of this LOS in about 30 seconds.
Now in a handover of some of those tracking and data relay satellite communications that provide video and audio from the International Space Station. Should be regaining audio communications here in just a few seconds, video communications after that. So far, Parmitano and Morgan have made their way to the work site and completed the setup. They brought the tools and the new pump over to the alpha magnetic spectrometer. Now working to install the pump. That's the next in their task list. They've docked it to its ports and they've driven all 4 bolts that hold it into place. The installation will be sort of complete once all the cables have been routed. That includes data and power. That'll be the primary job of Luca Parmitano, who has good access from the end of the station's robotic arm. In the meantime, Andrew Morgan will be working on some of the preparations for that next step, which is to connect or swage some of the tubes. This will be the primary time constraint for the spacewalk today. Requires intricate work for tiny tubes using a swage connector.
All right, Luca, you'll take the cap keeper from Drew, and then you need to retrieve the power and data cables that you temp stowed on the ROU, and then we're going to remove the cap.
I have them right. I have them in reach. Yeah, in a good position for me to install them. I have the cap keeper.
Okay. All right, great. You can remove all 4 caps and call them out.
Cap keeper to Luca.
Here's the red back.
Have the red back.
Okay, I'm removing J1 from the pump.
Regaining some of that communication from the International Space Station. Some of the views here you're seeing getting a little darker. International Space Station flying 263 statute miles in an orbital nighttime just over Mongolia.
And J1, he's got good pins.
Copy.
For J2.
From the helmet camera of Luca Parmitano, you can tell by the translucent numbers at the bottom right of the screen. He'll be helmet camera number 11 for today's spacewalk. He's again positioned upside down, so some of the markings there are upside down from his view. But right there in front of him are some of the connectors he'll use. The data cables and power cables have been pre-routed into position, allowing him access to just make the connections from there. Those pre-routing procedures took place during the previous spacewalk.
This one is it's T2, which goes to J2. Shooting the cap.
Okay, that's right.
Okay, cap removed. And on this side, I have no FOD, a good EMI band. Do you want me to retrieve the other cables first before I install J2, or can I install J2?
Here, go to install J2, Luca. It goes to P2.
Please go to install P2 to P2.
That's it. Just double check the no FOD pins and EMI for us.
Yeah, one more time. On J2, I have good pins, no FOD. And on P2, I have no FOD and a good EMI band.
Okay, go to mate.
Okay, mate. Mate. And overset the lever forward. Full test.
All right, good stuff. All right, next you can do P1. Drew, I see we just got WVS back on both of you, so that's good news for us. I see you working the tool board. And then having one mini workstation right available for the plugs, should already have. And Drew, cap keepers from crew lot bag 3. It's all swaging items.
Roger, all available.
Yeah, good pins, no FOD, and good EMI band on J1 and T1.
Okay, go to mate.
And ready to connect with your girl.
Go to mate.
You work.
This is Mission Control Houston from the helmet camera of Luca Parmitano making those connections. The power and data cables were routed on a previous spacewalk to allow easy access for Parmitano to make the connections. Now that the UTTPS, the Upgraded Tracker Thermal Pump System, is the name of the new pump system that's currently installed by 4 bolts on the outside of the AMS. That'll be its home for the remainder of the life of the alpha magnetic spectrometer. Now just making those power and data connections. Mission Control will power it up, just make sure everything's good to go on the pump system and everything's working. And then they'll move on to the swaging of tubes. That's connecting the tubes that have been cut on a previous spacewalk. Drew Morgan standing by for preparations on that task.
IVA on the UTTPS to tether those wires.
Work.
We picked the right corner, Luca.
I sure did.
Okay, Luca, you've got everything connected. We're going to power up the box if you're good with that.
I'm very happy with that. Crossing my fingers, crossing my gloved finger and my booted toes.
The moment of truth, Luca Parmitano make those power connections. From here in Mission Control, Houston, working with the Payload Operations Center in Marshall Space Flight Center, they'll check the power of the box, make sure everything's working.
There.
All right, that'll do. I'll take a glove check while you're at it.
Okay. I uncrossed my gloves and they are still pristine. I do see there was a little bit of discoloration from one of the capsule cables, but it's gone. And other than that, they are pristine. No changes, no deltas. Good app. Nice.
Okay, you can grab your PGT. We're going to set Alpha 4, clockwise 1.
Alpha 4, clockwise 1.
Yeah, and I miscalled that, Luca. It's counter 1. Alpha 4, counter 1.
Alpha 4, counter 1. Okay, Alpha. Counter 1.
While the pump system is still powering up, Luca Parmitano preparing that space drill for the next set of tasks.
Alpha 4, counter 1.
Okay, those are good settings. You can stand by. And you are now go to open the refill valve. This is important, though, Luca. It's not to hard stop. We're only going 1 to 1 1/4 turns.
Hey, Drew.
How copy, Luca? You got that? 1 to 1 1/4 turns only?
1 to 1 1/4.
That's it. And then you'll read the turns, and we're just curious what torque value you're going to get, but it'll be a low torque.
Okay.
Okay, and stand by, Luca. So I got a good view of the black line, so I can call the stop.
Okay, so do I.
Okay, great.
Ready? Let's go. Starting.
Great.
One turn. And the torque is 2.3.
Okay, we got it. 1 turn, 2.3. Good job. All right, you're handing that PGT over to Drew. Drew, you're putting it in a green bag. Fish stringer hook 6. And then you're ready to...
I'm going to give you...
Yeah, I have a red on it.
Okay. And I'm keeping these red, Drew, so that then I have it for the camera.
Yeah.
Okay.
I have it. And
Parmitano completing the use of that pistol grip tool, handing off to Andrew Morgan, standing by.
You're heading to the VSB.
Drew, do you want to give me the camera letter?
I can give it to you сейчас.
Are you ready for brakes off?
You can go brakes off, Jessica.
Okay, copy. I'm going to take brakes off, and then the first thing we'll do is get set up to take out that 40 centimeters. So I'll bring you 40 centimeters to your left.
Stand by for that.
No, we do have a ret on here for you already.
Okay, that's too many. You think you can get rid of that one?
I can. But I don't think we want to delay the. It's going to take me a second, so I'd say go ahead with the repair.
All right. And Jessica, you go for motion. Jessica, you copy?
And Luca, stand by. We're actually going to get set up that we're just going to not have to take out that input. We're just going to have to bring you back to Station Zenith.
Copy.
For our bookkeeping, the small ret associated with GoPro and CrewLock Back 4 is going to stay, and we're going to use because PGT ret and the integral.
Okay, copy that, Drew.
Okay, Luca, and we are ready for that motion. If you are, it'll be bringing you Station Zenith, same as before, so a little bit less than 2 meters.
Stand by. 30 seconds.
Copy.
Jessica, you go for motion.
Okay, and Drew, you ready with the clearances as well?
Ready.
Okay, starting motion, Station Zenith.
Back. Now lean forward. Lean forward, Luca. That's good.
So now that Parmitano has made those connections of power and data cables from this position, sort of upside down from the perspective of the alpha magnetic spectrometer, Jessica Meir now maneuvering the station's robotic arm. She'll position him essentially in the opposite direction. He'll be turned around and facing right side up, which will allow him great access to some of the tubes. That'll be the next part of the task. Those tubes have already been cut on the previous spacewalk using a rough cutter. There'll be the rough cut tubes will be clean cut to allow them to be a nice uniform shape, and then start the swaging process. The swaging devices, the alternate fitting, are currently on the box. They'll be taken off and installed one by one on the tubes that are cut. Once they're clean cut and have a nice round shape to them, and measured using some of the tools that have been specifically designed for this spacewalk, including a straightener. That's also a straightener and a measuring device. Before we get to that, Parmitano still making his way over to the worksite. Morgan standing by with all the tools in hand.
Position hold, Luca. We'll load the next JoeCast.
Copy.
So again, Parmitano making his way over to the new position.
Yeah, we're looking real good. No issues on that front so far.
How about time?
Also good. I'm not going to give you any bad news. You can keep asking me, but I'm just going to tell you it's good. We're looking great.
Just like to hear it.
Parmitano positioned essentially upside down with his head facing towards the Earth to give him good access to that work site, connecting those power and data cables, all complete. The new box installed onto the alpha magnetic spectrometer. The next more complicated set of tasks include swaging some of the tubes that have been cut on a previous spacewalk. Those tubes were rough cut and capped off and labeled so that Parmitano will know which tube goes where. There's 8 total. 6 of them will be at the work site that he'll work, that he's heading to right now. That's at that vertical support beam, one of the best points of entry for accessing the tubes and connecting to the new box. The other 2 tubes will be, Parmitano will have to be repositioned to another point of the alpha magnetic spectrometer.
We have good insight into the new pump box. We got good power, good pressure, and we can tell the refill valve is open. So that's excellent.
All right, that warms my tips better than the glove heaters. And the gloves are good shape, no changes, no deltas, good happen.
Good news. Weed shows that we can tear things apart and build them back up.
Yeah, we got a little ways to go yet, but we agree. We're looking good. How about a glove and half from you, Drew?
Gloves are no change, and half is dry.
Here's position hold, Luca. We'll load the next JoeCast.
Copy, standing by.
Drew, how are you doing for time? Or there's a potential get-ahead task if you have the space and time to do it.
Name the task. Was this to take a look at the mud flap?
No, we're not going to do that today. It would be to have you go up and look at the tube restraint blanket by the AAS and see if you can remove that. We're going to have Luca do it as soon as he gets there, unless you can reach it.
Roger, let me take a look.
Luca, ready to start this JoeCast, 1.5 minutes.
Copy.
Motion.
Jessica Meir continuing to maneuver the station's robotic arm. At the end, Luca Parmitano being repositioned to his new work site to work on those 6 tubes for swaging, essentially connecting them to the new box. You heard reports from the ground here in Mission Control Houston. That new box powered up, pressure's good. Everything's working as planned so far. Ahead of the timeline at this point, giving Drew Morgan enough time to do a get-ahead task, maybe get some work done before Luca Parmitano gets to his new work site.
Yeah, this is a nice to-do, so use your judgment here. We're not too concerned about saving the 30 seconds.
So watch out for the number 7 there.
Yeah, yes, this is the 7 here. Wait a little bit, but
Jeremy, I'm right here. So
Yep, no issues.
you're ready to go into the position.
Okay. Your call, guys.
yeah, let me back out of the
Yeah,
way.
so I'm right here.
Luca, here's position hold. We're going to switch over to manual for the next maneuver.
Ready.
Hey, Luca, this is going to be bringing you a little bit less than a meter station forward, so it's for you up.
Copy.
Okay, ready for motion?
Ready for motion.
Okay, starting motion.
Motion.
Copy, 50 to go.
Yeah, this is where you get real close to blue plate, but I see you clear. To your left a little bit. Or your right? So, nope, your left. That's good. We're good.
There's your position.
Copy.
Luca, this next motion is going to be bringing you in toward the VSB worksite.
Copy. Ready.
Starting motion.
You're getting a live view from the helmet camera of Luca Parmitano.
Motion.
Copy, 10 degrees to go.
Good clearance. It's your left shoulder.
Starting to come into view, you can see those tubes all capped off, those silver circles there. There's 6 of them that Parmitano will have to work with. He'll be in a good position.
That position, we're going to switch over to snapshot, and then we will go with the published GCA inputs that we have.
Excellent.
Okay, Luca, we are all set up. The first input is going to be a roll to your right, 15 degrees.
Copy. That will help with my clearance.
Okay, ready for motion?
Ready for motion.
Starting motion.
Clearance.
And Drew, you're watching Luca and the APFR to the row U.
Copy.
Halfway there now.
Copy.
Continuing to work through the procedures to grant Luca Parmitano access to the VSB, that's the vertical support beam worksite. The vertical support beam.
Roll, now I'm going to be coming to your right about 30 centimeters.
Copy.
And Drew, you'll be looking at the clearance from Luca to AMS.
Copy. I have the clearance.
Starting motion.
The vertical support beam underneath was those tubes Support beam was removed and jettisoned overboard, allowing access to the tubes, which have been rough cut and capped off on the previous spacewalk. Parmitano will be spending the majority of today's spacewalk here at this worksite.
And Drew, for you, that's going to be the boot plate and the wrist to the diagonal beam.
Copy. I have them in sight.
Copy. Starting motion.
Good motion, good clearance.
Okay, there's your published, and now I'm going to roll you further another 15 degrees to the right.
Stand by.
Standing by.
Was that, you said the last motion?
No, what we have for the published would be continuing your roll another 15 degrees to the right, pitching you down about 8 degrees, and then bringing you in 40 centimeters.
Okay, then continue.
See, I'll start with the roll to the right. And Drew, same as before, and that will be Luca and the APFR to the row you.
Copy.
Starting motion.
Good motion and good clearance.
Continuing.
Jessica Meir on the inside of the space station at the controls of the robotic arm, assisted by Christina Cook. Maneuvering Luca Parmitano into position at the work site next to the tubes. He'll spend the majority of his time there, working with his intricate set of specially designed tools to clean, cut, and swage or connect the tubes to the new pump box. As these maneuvers are underway, we're looking forward to sunrise in about 4 minutes.
Clearance.
Copy. Okay, Luca, that is the end of the pitch. Now I'm going to bring you in, body in, 40 centimeters.
Okay, copy.
And Drew, this will be, of course, Luca's clearance to AMF.
Copy.
Starting motion.
Clearance.
3, 2, 1, stop motion.
Copy motion, and that is right at our published.
Wow. Okay. We are ready. GCA complete.
GCA complete?
Okay, Drew.
And you're ready for the next
Luca
step.
needs a MWS RET from you. The sun will be coming up here in just a minute or two. And a warning here, Luca, reminding you about the sharp edges, the nut plates on the back of the IPA and the VSB.
Copy.
Luca, we will leave the brakes off unless you tell us otherwise.
Thank you.
Okay, Luca, as you receive that RET from Drew, you're going to put it on the tube restraint blanket, and then you can release the integral hook that's on the UTTPS. It's on the forward handrail, and remove the blanket. Remember, a reminder about the Velcro saver. We want to make sure it all stays on.
Copy. Copy all, Jeremy.
This is going in the green bag, correct? All right.
That's right, hook 5. Next thing you're getting ready, Drew, is the 7/8 wrench.
From the helmet camera of Luca Parmitano, you see him holding on to that box he just installed, the new pump box. Removing the blanket that's revealing some of the tubes that will be used to connect here very shortly.
It doesn't look like a burrito to him. It looks like a cannoli siciliani.
It's a very neat to say right now, but thanks. They're both delicious.
No doubt. I'm sure he's happy-go-lucky about that. All right, Luca, so you're looking for picking your first AAF that you're going to use today. Reminder on those, as you pull them out, grab behind the AAF so you don't inadvertently rotate the swage setting.
Copy. Okay, the first one out is number 6.
Okay. It's 6. And Luca, do you see the Velcro saver on all 3 sides is still in place? We can see some of it in your WVS.
I did check the aft side over here. I cannot really see the bottom, but I do see the beginning and the end of it being flat. So I see 3 out of 4 sides.
Okay, copy that.
Velcro saver.
That's good. So we copy you've got tube 6. You can go ahead and remove the MLI. Drew, we need a RET for the plug, and you can report the initial numbers, Luca.
So, one by one, Luca Parmitano will remove the covers from the tubes, revealing the alternate fitting underneath. This alternate fitting will be the tool that you'll hear a lot during these next few steps to do each tube one by one. This is the tool that will be used to connect the tubes that are currently capped off to the new pump box. That bolt you see in the middle will be turned by a wrench, and that'll complete the swaging technique, essentially pinching the tubes, mating them together, and allowing the flow of carbon dioxide for the cooling of the alpha magnetic spectrometer.
Okay, the first setting that I see before even removing anything, I have Foxtrot 7. The line, black line,
Okay.
in place.
As expected, Foxtrot 7's good. You open the handle, you can secure it with a wrench, and then you can open the VLI.
Temporarily, this retaining blanket, I'm going to put it over at the red bag just to keep it really busy at the green bag, so I think I'm just going to put it over there for a little while.
Okay. Are you putting it in the red bag or just near it?
Nothing's really in a bag per se right now, but in the general vicinity of it, it's on the lid.
Okay. Understood.
Okay, I made the spot, one turn back after fully releasing the VLI. I still have a Foxtrot 7, no changes. Okay, closing it back.
Okay. Good job, Luca. It's like you practiced this. All right, so next we're going to go ahead and perform the clean cut. Let's make sure we get the right one. So tube 6.
Cutter staged here for you, Luke, when you're ready.
All right.
Okay, and let's, we'll need it. And you don't need to put the MLI back on, Luca.
I'm just trying to position it so that I can move it.
Okay, we want to ret to cap 6.
Ret for cap.
Drew, make sure the clean cutter is prepped.
Clean cutters set.
From the helmet camera of Andrew Morgan, Morgan's job is to work with the tool board containing all of the necessary tools for Luca Parmitano, who has the best access to the worksite right now. Those little tubes to be cut by a clean cutter. There's the one on the top right here. A very intelligently designed cutter. The knob on the back there will be used to cut the tube uniformly across the entire surface, allowing for no imperfections and a nice clean cut, why it's called the clean cutter. And that allows it to be mated to that alternate fitting for a good swage or a good connection for a tight seal. There's the clean cutter right now, so you can turning the knob there for a nice clean cut. The cap at the end secured by a tether, so whenever the tube is cut, the tether will pull away the cap.
Yeah, we're watching you, Luca. You're doing all the right things. We had the same questions down here. You're reading our mind.
Yeah, I was spinning. It's okay. There we go. Okay.
Okay, that looks good, Luca. Now the extraordinary patience required part. And warning, as that does cut, we want you to avoid contact with the ends of the tube.
Again, Parmitano working with those specially designed tools. This is a very delicate part of the procedures to clean cut the tube. As Jeremy Hansen here in Mission Control Houston mentions, it's a delicate procedure and time-consuming.
Great on time today, so we'll just take our time with this. This is exactly what we came out to do today. Drew, next is the straightener.
Deep 6. Or cap for 26 back to me.
Nice.
Okay, here's the straightener. We'll see how this works coming off the board.
A nice clean cut by Parmitano. Tube 6, the first of 6 for this work site. The next thing he's doing is using another tool specially designed for the spacewalk called the tube straightener. Does exactly what it sounds like. Make sure that tube is straight for the length that's specified in the straightener. What he'll do is he'll straighten it. He'll mark it off with some Kapton tape. That tape will mark how far it is to be pushed into the alternate fitting for swaging.
Okay, and we'll need tape next, Drew.
Okay.
The length must be very precise for a good swage, making sure that the connection of the tubes is good, that it's tight and sealed
I see one problem with
to allow the flow of carbon dioxide.
restricting how we can answer the tape here. Okay, I'm here for number 7, Tamara George.
Number 7, Tamara George, coming off the board.
Looks like it came off cleanly.
So as you put that tape on, just make sure we're all the way in the window, Luca, on the straightener.
I'm going to double check on the outside gauge.
Copy that.
The tape is all the way touching the edge, so it's perfect gauge.
Okay, excellent. So now you can line up the AAF with the tube. We'll double check the numbers and then insert it.
Okay, I confirm I have Foxtrot 7.
Okay, that's as expected, Luca.
Tube 6 has been clean cut and marked off with tape, using the clean cutter and the straightener to get it ready for swaging with the alternate fitting.
Okay, I'm inside the AAF, and I'm about past the black line. I'm about half an inch still to go.
Okay.
I want to force it more than that. It's definitely in past the line.
Okay, Luca. We're handing over in 30 seconds, Luca, so you can go ahead and get ready to swage, but how about you wait for us on the other side before you actually turn the wrench.
Fine. Yes, we'll do that.
Now in the middle of a short handover period, you're getting a look at the inside of the International Space Station Flight Control Room. Teams here looking over the International Space Station systems as well as the procedures for today's spacewalk. Teams here led by Flight Director Emily Nilsson. The voice you're hearing is Jeremy Hansen, the ground IV, communicating with the crew from here in Mission Control Houston. At the forward end of the screen, you see Jeff Radigan, who was the flight director for the first 2 spacewalks. Emily Nelson will be taking over for the next 2.
Okay, Luca, we're back with you. So keeping an eye on the tape and making sure it doesn't move out of the AAF at all. That's the key point here, especially since we're already half an inch out. Your go-ahead to give it 1 turn clockwise.
Clockwise. Numbers increased.
Okay, keep an eye on the tape. We don't have WVS, so you guys, it's all on you to watch the tape.
I have good eyes on the tape.
Regaining some video communications from the International Space Station. Luca Parmitano undergoing the swaging
That's what you're looking for. Just
of the tubes.
We're back on WVS. Everything looks good.
You see him using a wrench with the alternate fitting, that AAF. Here's the tool he's using now. There's a little bolt in the middle there, all numbered, doing a very small turn, and all he's doing is just pinching that tube to the alternate fitting to ensure a good fit and good flow of carbon dioxide. Just a simple 7/8 of an inch wrench there. A small turn, but it should ensure a good fit. He'll have to do this 6 times at this work site.
I have Foxtrot 7 up and 6. The tape hasn't moved. I have a good full test.
Okay, good. Great swage. Next is to tighten the VLI handle. Remember, give it a good firm tighten. And then we'll cycle the cap, close everything up. And I don't know how we didn't really talk about this, about taking a photo of these prior to putting the MLI on. I don't know if that's practical or not. But we are doing reasonable on time today. That seemed to go pretty smooth, so we probably could take a photo.
Want a photo of what?
A photo of the AF before you pull the MLI over it.
Yeah, that's it.
Okay.
Nobody's actually asking you to do that. I just thought it was an idea you might want to take advantage of.
And if the VLI is open still.
It's really close. I don't know if the camera in a good position to focus on it.
Yeah, understood. GoPro might be the better way to capture these AAFs. I don't know if that's going to be handy or not for future ones, but this is fine for now.
Exactly the cap.
Okay. And I think I saw you tighten the VLI all the way.
I did. It was all tight, and
all right. Cover it up with the MLI. We're done. 1 down. 7 to go.
it was 6. Going up and away.
Okay. All right. That's great. So just a technique observation in case it's helpful. Looks like you're doing these like with the tube directly pointed at your chest. If that's awkward, don't be afraid to change the orientation of the tube coming out of the VSP.
Copy.
All right.
Okay,
Pick your next lucky tube.
I think next one is 7.
Okay, whatever one's convenient.
Will be 7.
Okay, we'll take 7.
7.
Drew, we need a ret.
For the plug.
This is Mission Control Houston. As mentioned, the first of 6 tubes on this work site are completed. There's 2 more on the other side to make 8 tubes. You'll basically be repeating the process 8 times for swaging the tubes to the new pump box.
I have Hotel 6.
Hotel 6 is a good number.
Okay, opening up.
Okay, I'm watching the WVS. Everything's looking good, Luca. To get the wrench on, you go to open the VLI.
I have to look. One turn back, and Hotel 6. There was a slight motion to a smaller number. So now the line is a little misaligned, but in the good direction. So I think I'm not going to do anything.
Yep, it's a good call, Luca. All right, you can set that aside. Now we need to ret to tube 7.
Yeah, ret ready.
Drew, you can get the clean cutter ready.
Clean cutter is ready.
Okay, ret.
All right, ret for 7. Clean cutter is right in front there, and it's set. You have a ret on the cap. Here's clean cutter, it's set.
Drew, next is the straightener.
Back to me. See the straightener back. Here's the straightener. Here's the straightener. It's got the clean cutter.
Clean cutting for tube number 7 complete. Going to repeat the process for each of these tubes using the straightener to make sure it's nice and even for the length of the swaging needed.
Ready for tape.
Marked off with tape and then connected to the swage, the alternate fitting.
Nice straight tube.
What do we have, Drew?
Okay, here's One right here. That's got serial number 23, Tara Yoakum.
Say number 23, Tara, you're on. Safety's on, and I'm going to go on the outer gauge to judge it. And again, I'm right on the edge.
Okay, Luca.
Okay, I still have Hotel 6 still in place.
Okay, I heard Hotel 6, Luca. That's a good number.
Hotel 6. That's a good number.
Now you can align them and insert it.
Okay, this one is maybe a little less than a quarter of an inch from the line.
Okay, we copy, Luca. That looks good. Your go ahead. Well, as long as you monitor that tape, your go to swage 1 turn.
Copy. More.
The cap and the plug are retained on the cap keeper's read.
Okay, copy, Drew.
No motion.
Spacewalkers ahead of the timeline, 2 hours 23 minutes into today's spacewalk. Parmitano working to swage or connect the tubes that were cut previously on the last spacewalk and clean cut just prior to this swaging.
Hotel 6, take a pull check.
A quarter of an inch. I have a good move check.
All right, tighten VLI.
And work. Close cap. Close the VLI. Close the handle.
Have a picture if you can.
Dude, you have the camera.
I do. The problem is their shoulder is kind of between me and a good shot. Let me see.
We're doing good on time. What about grabbing the GoPro, Luca? Do you have it on your swing arm still or not?
It's on my swing arm. Yeah.
Can you get it off for you?
You can pass me yours.
It's easier for me to actually pop yours on and off than mine, and yours is running on front right now.
Okay.
While he's doing that, Luca, let's see if you can help our view out a little bit so we can back you up. That tube 6 that you have up there, just push it off to your left.
This one?
Yeah.
It's just right in the WVS when you lean forward into your work envelope.
So here's 7 right there.
Yeah, that should help. Thanks. If you just push that one down, I don't know if that'll be in your work envelope, Luca, or not, instead of up. Yeah, that's fine too. That works great.
It's easier when I have it, if you don't mind.
No, we'll work with it for sure. Okay, let's pick the next one.
Going down, so. Yeah, I'm going for number 3. Are you ready for red? Not quite.
2 tubes down of the 6 that are at this work site, tubes 6 and 7. Parmitano working on 3. Tubes 2 and 4 are on the other side of the alpha magnetic spectrometer. Will require a little bit of repositioning after they finish up with these 6, but essentially we'll be repeating the process 8 times. First preparing the alternate fitting, then clean cutting the tubes that are capped off to allow for a good swage, but first measuring and straightening with the straightening tool, marking off with tape, putting into the fitting, and then swaging or pinching the tubes together.
Maybe 4 pounds. Here's the red one, yeah. Okay, you can put the red on. Red's on. And I have number 3. It's Charlie 6. Charlie 6.
Charlie 6 is good, Luca. All right. Next is wrench and loosen the VLI.
What's that to me?
Okay, I saw the VLI is tightened. One turn. Set that aside. Charlie 6. And next we're going to go ret to cap 3. And then Drew, get the clean cutter ready.
Clean cutter is prepped. That is in hand.
Up. And clean cutter.
The clean cutter is aged there and set.
Okay, Drew, next you can get the straightener.
Okay, in hand.
It looks like this cart is unlocked, is locked.
Okay, ready to go. It's back to me, Mr. Straightener. That's the red length spin on the straightener. Okay.
What's that?
The red length on the straightener, okay?
That's fine. Thank you.
Okay, Drew, tape.
Okay, plug and cap on the cap keepers.
Copy.
All right, Drew, tape.
Back a little bit. It's down here in this corner. Looks like it's the one that has Brian Mader's name on it.
All right, it's serial number 25. Brian Mader. So are you on my, somehow on my list?
No. You may be, hold on, stand by. I think it may be, let me see, is it the ingress aid? What are you feeling?
Or is it tube
Or,
7? Tube 7 is maybe touching your WVS, Luca.
Okay. Okay. I have the tape installed. Check with the outer gauge.
Okay, copy that.
No, I have to retape. It moved while I was doing it.
Okay, copy that.
Able to get it off completely?
It's off completely, but I won't be able to re-put it.
Okay.
Certainly not representative of Mader's work. Amazing work on this project.
Not at all.
Next one is number 34.
Nowarsky.
Well, let me put the strainer first, and then I'll.
Yeah.
Well, that's the first time it's happened to me. Yeah, I'm all the way here. You put the tube in the window. And I'm locking it in place. And now you can give me number 24.
You see it?
John Morarsky. Okay, John, call out for you.
For a good swage, the tube has to be put into the alternate fitting, a very specific length, marked off by the Kapton tape, measured by the tube straightener, both in the hands of Luca Parmitano right now. Those precise measurements required for a good swage to make sure it's pinched at just the right point.
These one's on.
Parmitano just working to make sure that that measurement is precise.
Yeah, it's the tension on the right of the tube strainer is messing me up.
Okay, I think we should put it on a ret to you then. I think that'll be that'll.
This is too short. Again. Don't have to come on a ret on me every time. I'll just do that right now. How many days do we have left?
Plenty.
Tube strainer is on me.
I'll give them a count just so there, but let's see. 1, 2, 3. Like 11 or so.
Yeah, sorry guys, this is unexpected. I've seen this happen before. for the last time.
We know what you're trying to do. You're just trying to honor more people from the team.
I see the tube in the window. You said they're fully locked. Okay, Drew.
Okay. And you feel like there's no competing tension on that?
Well, I'm gonna lock it. I'm gonna lock it until I release it. Okay, which one?
Let's take this blank one here. That's 14 for now.
Okay, blank 14.
See that blank one, yeah. The one next to it, if you see it, it's like it might tear, so we're not going to use that one.
Okay.
I won't let you grab it.
Okay, we'll use it as a spare. It is on. I can still see the window. Open it up. And again, I'm going to double check it against the outside. Okay, now I have a good one. Right on the edge.
Okay. Let's line it up with the AAF.
Grab it again. AF3.
Check the number, Luca. What do you got?
It was 3. Charlie 6.
Charlie 6?
Corner ring.
Copy.
Yeah, and I am about a quarter away. So I call it a good one.
Okay. Copy. You're a bit broken there. It sounded like a quarter inch. And your go to swage. Let's keep an eye on the tape. We can't see in your WVS, so let's make sure you monitor the tape. That tube 7 is in our way again.
Monitor the tape. Copy. Monitor the tape.
You're going to feel me on your swing arm here for a second.
Keep your ear down because I don't want to move.
Okay, I'm done.
Okay, Luca, keep an eye on the tape. One turn on the swage. Looking for Charlie 6.
Actually, from this position, I see Bravo 7 and Alpha 8, which are equivalent.
Okay, copy. Bravo 7, that works.
I'm at Bravo 6. One more 8 more turn.
Copy.
It is good. But the flop of the reader is perfectly in front of my eyes.
Luca, I didn't actually copy your last.
It was just a matter of BCD that couldn't quite see the corner range. But I have Bravo 7.
Okay.
Lined up.
Bravo 7. Take a pull test.
Yeah, and I can see that Hotel 1 double lines lined up. Safety is about a quarter of an inch to the food. And I have
Okay. That's a good switch.
Tighten the VLI.
A-firm. Go for it. And did you get a pull test, Luca?
Yes, I have a good pull test. Cycle the cap, closing the handle.
Here's the GoPro for the survey.
Okay. And just a quick GoPro survey, and then we'll move on.
Right there.
Okay, you can button that one up, Luca. And we're on to the next one.
It worked.
Halfway done at this work site. 6 tubes at the vertical support beam there. Tubes 6, 7, and 3 now complete.
Next one is number 1.
Okay. Drew, we need a rep for the plug. And if it's convenient, Luca, push that 7 out of the way again. Just got caught in your WVS. Helps us help you if we can see what you're doing.
That WVS for me, and is it helpful at all?
That's good. Ready for it with the...
Luca Parmitano at the end of the station's robotic arm, continuing to work through those procedures to swage or connect the tubes to the new pump box.
WVS, but it's not very useful for...
Andrew Morgan off to the side,
Go ahead, Luca.
I have Foxtrot 7.
working together to
Okay.
hand over the necessary tools for the tube connection process.
Support it with a wrench and open the VLI. I'll see you on the other side, about 30 seconds.
Copy.
We're in a short handover of video and audio communications from the International Space Station. Should be regaining audio very shortly. There's a live look at the inside of the International Space Station Flight Control Room. Teams here overseeing the procedures, talking with the crew aboard the International Space Station, and working through the repair of the alpha magnetic spectrometer. While we go through, we'll be answering questions using the hashtag AskNASA. We have one from Michelle, who's asking how the procedures for practicing the spacewalks and how the situations are simulated on the interior of the space station. Spacewalks themselves, basic skills, are practiced in a big pool called the Neutral Buoyancy Laboratory. It's a very deep pool, and inside can be full-scale mock-ups of the International Space Station. They practice general spacewalking techniques, but also had a chance to go in the pool, both Parmitano and Morgan, to practice some of the techniques for the alpha magnetic spectrometer. There's also an active gravity response offload system that also simulates a lack of gravity and allows them to practice on a more higher fidelity mock-up. Whereas being underwater, you have limitations on how detailed you can get with some of the mock-up abilities. For the interior of the space station, there's a few facilities where you can practice, particularly the robotic arm that Jessica Meir is controlling. There's a virtual reality dome here at the space station to go through some of those techniques, as well as the many other techniques for the racks on the inside of the space station. regaining some of that video communication back for the Alpha Magnetic Spectrometer spacewalk. Parmitano done with half of the tubes here at this worksite, working on tube 1. Now bringing out that clean cutter tool, turning the knob, and he'll essentially ratchet it slowly but surely to make a nice clean cut and allow for a good end to the tube. No pinching, a nice clean surface for the swaging process. There's an alternate fitting where the tube can fit in nicely. Of course, after a little bit of straightening and marking off with Kapton tape to ensure it's just the right length to go into that swaging tool, or the alternate fitting. Parmitano completing this process 3 times, 3 more times at this work site, then they'll maneuver to the next work site on the other side of the space of the Alpha Magnetic Spectrometer for the last 2 tubes. He's working on tube number 1 at this work site. He has tubes 5 and 8. And then on the other side, he'll complete the swaging process with tubes 2 and 4.
Drew, next is the straightener. I guess it's on Luca now, though, isn't it?
Yeah, we're going to leave it on Luca because of that tension issue. Okay, cap is back to me. Well done, Luca. I know that's getting old. One. Have one in my hand. Okay. Straightener. Straightener's right there.
Nice clean cut for tube 1. Next will be to put it in the straightener, make sure it's nice and straight. It also serves as a measuring tool. So Parmitano will mark it off with some Kapton tape. That's that orange tape you see on some of the other tubes. And that'll ensure how deep to put it into the alternate fitting for a good swage, where the tubes will be pinched together for a nice flow of carbon dioxide, which is the cooling, which is used to cool the Alpha Magnetic Spectrometer.
Okay. This right here. Put your right arm down a little bit. Put your right arm down. Number 11 there is has Derek Porter's name on it.
Okay. Coming out. Derek Porter. First base deleted.
And did you have something for me?
No, I just said tape was the last thing I called.
Okay, copy. Roger.
double check with the gauge. Hey, I'm about this one.
Say again, Luca.
So the tape was about 1 millimeter away from the edge.
Okay, copy. Every once in a while, your comm just breaks up. That's all.
So do yours.
No doubt. Okay, so let's make sure.
I got Foxtrot 7.
That's a good number, Luca. You go ahead to install it.
Okay, I'm inserted, and I am about, again, the typical quarter-inch away from the VLI handle. Make sure that there is no motion from the tape.
Okay, that looks good. Your go to swage. Keep an eye on the tape.
That's just a little tap from me, sorry.
Okay, keep an eye on the tape.
You see the line on the tape? No motion on the tape.
Okay, you're going to Foxtrot 7, if that's what you can see.
Foxtrot 7. Alright, Foxtrot 7, lined up.
Okay, that's a good number, Luca.
The tape is about, yes, ready to seal the VLI.
Okay, good. Let's get a good pull test first. I didn't hear if you got a pull test, Luca, before the VLI.
VLI tight.
So hang on. So hang on, Luca, 1 sec. Did you do the pull test before the VLI or not?
Yeah. I didn't mention it, but I did do the full test as soon as I finished staging.
Yeah, okay. That's what we were missing there. Okay, and now you've tightened the VLI, cycled the cap, and you can take a couple photos or quickly inspect it and close up the AMLI.
It's GoPro.
GoPro video.
Okay, that's good.
Moving the handle and covering with the VLI. Recovering with the MLI.
Fourth tube complete. Nice video survey. in reference to the VLI. That's the Visual Leak Indicator. That'll be used on the next spacewalk to ensure that each of the tubes has a good swage and that the carbon dioxide flows neatly through all of the tubes without any leaks. But for now, the clean cutting and the connecting of the tubes is the primary task for this spacewalk.
No change and dry half.
All right. Which tube is next?
Number 8.
Okay, we're ready for 8. Drew, we'll need a plug for the, or a ret for the plug, and we'll take a glove and half from you as well.
Copy. I just checked my gloves. No change. They look still pristine. My half is dry. I've got a ret ready.
Yeah, your procedure goes for 5 first. That becomes a little easier. If that's okay.
We have no preference. We're happy with 8.
Again, 6 tubes at this work site, 4 down, 2 to go. There's another 2 on the other side of the alpha magnetic spectrometer. Tubes 6, 7, 3, and 1 successfully swaged. Luca Parmitano on to number 8.
This one is number 8 again, and I have Bravo 4.
Okay, good numbers. And you're ready for the wrench. Open the VLI.
There is a red on the plug if we didn't call, so.
Copy. We're visual.
I have the plug back.
Okay, Bravo 4, confirm. Doesn't move.
Okay. Bravo 4, that's good. And just confirm you only got one turn of tightening that VLI, correct?
It's about 1.5, because otherwise, it doesn't line up with the handle.
Okay. Drew, we'll need a ret for the cap and the clean cutter.
Clean cutter is set. And, yeah, ret for the cap.
That's for the cap.
A good pace. Let's keep it up. Here's the clean cutter set.
Be set.
The space station and the 2 spacewalking astronauts now in an orbital nighttime, 263 statute miles over northern China. 3 hours into today's spacewalk. They're the 2 spacewalking astronauts a little bit ahead of the timeline. Now on the 5th of 6 tubes at this particular work site.
30 seconds, we'll be handing over, guys. We'll see you on the other side. And we're doing real good on timeline. We're staying on target. So we just got to keep up the pace, and we're going to be in great shape. We'll talk to you on the other side. And consumables are looking good. Oh, and we are 3 hours into the EVA, just for your essay.
Now another handover of video and audio communications from the station. Should be regaining audio communications shortly as Parmitano continues to clean cut the 5th of 6 tubes that are at this particular work site. There's 2 more on the other side. In the meantime, keep sending in your questions using the hashtag AskNASA. This next question comes from Anson, who's asking what kind of material goes into these tubes. The tubes they're cutting are stainless steel. They're thin enough that they can be bent. A lot of testing on the ground and maneuvering of the tubes ensured that no matter really which way they're bent, the flow of carbon dioxide remains the same, so the integrity of the tubes themselves are retained. Keep sending in your questions using the hashtag AskNASA. In the meantime, regaining some of those video communications. This is the helmet camera of European Space Agency astronaut Luca Parmitano. He'll be the helmet camera number 11, the translucent numbers at the bottom right there.
We're back with you. Looks like you're on to straightening.
That's correct.
The clean cut of that 5th tube is complete. Working through those same procedures to use the tube straightener to ensure that the end of the tube is straight and then marked off at the precise measurement with Kapton tape. That's that orange tape. And that'll be the marker for how far to put the tube into the alternate fitting. That alternate fitting can be used with a wrench to drive a bolt that swages the tubes or sort of pinches them. And that pinch will ensure a nice seal. Seals will be checked on the next spacewalk, but for now, the clean cutting and swaging continues.
Okay, verify that it's on the window. This fully in. Putting the tape on. And verify with the outer gauge. Okay, I'm right on the edge.
All right, Luca. Let's check the swage numbers and let's install it. We're looking, put it in number 8. Just for my own benefit here, that cap that's still remaining, that's 5, right, Luca?
Yes, sir. That's 5 on the cap, and I have 5 on the remaining AES on the pump, other than the 2 that are still that are different
Okay.
lines.
Sounds good. Check the pre-swage number.
Okay. Pre-swage that number from here is the Alpha 5 on the decoder ring.
Okay, that's good.
The tube is in. Tube is in. I have the typical quarter-inch.
Perfect. Okay, your go to swage.
Okay, I'm going to look to the sheet that the tape doesn't move.
Perfect. Those are my favorite words.
You have eyes to it, right? I have eyes on you.
Okay, that looks good. Keep an eye on the tape.
The safety is not moving. Charlie, that was Alpha 5, confirmed.
Alpha 5.
Better to go the other way. And Alpha 5.
Okay, Alpha 5, let's get a pull test.
Good pull test. Typing the VLI. Cycle the cap. Crossing the VLI. Drew, you want to give it a view? Yes. Closing the handle.
Okay, nice job, Luca. One more to go at this work site. How are your hands holding up?
That's fine. So good. Yeah, supervisor. Sure. That's better. I forgot. I've done it too. Alright, number 5.
Okay, number 5.
Is this our SCVA too? Okay, yeah.
With the 5th tube complete, that's tubes 6, 7, 3, 1, and 8. He's moving on to tube number 5. That'll be the 6th here at the vertical support beam work site, where 6 of the 8 tubes are to be swaged. The remaining 2 will be swaged on the other side of the alpha magnetic spectrometer. Same steps as before, removing the alternate fitting cap.
For 5, I have Bravo 8.
Okay, Bravo 8, we're expecting Bravo 1-8, right in between.
Yeah, it's, I concur. I was battling between the two. I concur, it's Bravo 1-8.
All right, that's good. Go for wrench and then open the VLI.
So again, Parmitano will be setting up that alternate fitting, getting ready to receive the tube once it's clean cut. And then he'll move on to tube number 5, where he'll clean cut it, remove the cap. That cap will go over to Andrew Morgan standing by. He'll straighten the tube and mark it off with Kapton tape to measure the precise length that it will be inserted into the alternate fitting. And then he'll swage it to the alternate fitting. There's a little bolt there. He uses a wrench to swage or pinch the tube to the new fitting. And that'll complete the swaging process here at the vertical support beam work site. 6 tubes here. He's working on the 6th now. Again, there's 2 tubes on the other side of the alpha magnetic spectrometer. He'll perform the same steps there.
top end. On turn.
Okay, that looks good, Luca. Drew, next we need a ret to the cap, cap 5, and then clean cutter.
Okay, cap is going on. The red is going on cap 5.
Cap 5 is ready.
Okay, and here's a clean cutter set.
Move his.
Nicely done, Luca. Next is straightening.
All right.
And Drew, next for you is the tape.
Okay, 5's on the cap keeper, 4's on the cap keeper.
Copy.
Ready for tape?
Yep. Got,
Who do we have?
Justin Cassidy.
Oh. Nice. Okay. Seal number 21. It's Mr. Justin Cassidy. PP's on. Check against the outsider. Tape. Each. And it's right on the edge.
Okay, Luca. Let's go ahead and insert it. Report the swage number prior.
Confirm the number. Okay, I have Bravo 18.
Okay, that's a good number.
push the tube straightener in my direction, and I'll grab it from you. Send it down. Perfect, I got it.
Hey, Bravo 18, the tube went in all the way, less than a quarter inch of difference.
Okay.
And I'm ready to switch, and I'm going to make sure that there is no motion.
Okay.
Great.
Good words, Luca. Your go. Drew, as he's doing that, clean cutter is, if you have access to it, it's going back on the tool board. We'll get the wrench from Luca next. I know you're already taking care of the straightener. All right, Luca. Eye on the tape, and your go to switch.
Rush.
Eye on the tape. No motion.
Parmitano making that final connection, that final swage.
Gloves are aligned. No motion on the tape. I have a good pull press. And I'm tightening the VLI.
Okay. Sounds good, Luca.
That VLI, that visual leak indicator, will be used on the next spacewalk to ensure that each of these tubes has a nice tight seal to it and carbon dioxide is flowing nicely through all of them.
Double check the numbers for me.
Bravo 18.
Okay, Bravo 18.
And I thought that maybe you have it in the WDS, but it's not. You're taking a view with the camera.
All right. That's good, Luca. Take that photo. Then you can pass the wrench to Drew, close up the MLI, and then we'll take a few more closeout photos before you leave.
Yep. Sure.
That MLI is multi-layer insulation. It's that white cover that's going over the alternate fitting in the tubes.
Did you want the MLI over the scrunchies?
All 6 of them complete now.
Just a tiny bit of overlap is ideal, Luca. We just don't want any exposed metal.
Number 7 is the only one. Okay, very close.
You can flick the wrench down my direction.
Drew, while you're on the tool board, ideally we'll close the bunny ears on the clean cutter just to make sure nothing gets in there.
Closed.
Thank you.
Weed, I was going to suggest that if Luca could start to get tubes 2 and 4 mobilized out from behind the vacuum case handrail, it'll help me a lot.
Okay. We're good with that.
My GoPro back on his wing arm.
Roger, I'll do it. Okay, it's on its way on.
Okay, thanks. I'm going to take close-up features here. And then I'll pass you the tubes.
All you need to do is, I think, just get them a little bit freed up. That's it. Shine some extra light in there.
Yeah.
Parmitano and Morgan taking a survey of the worksite. All those 6 tubes swaged at this worksite.
3 hours, 20 minutes in, looking good.
The first thing, Luca, is I think if you get the tubes from, it looks like 6 and 7, make sure they're free of 2 and 4. And then if we can get those AS, yep, just wash from there. That looks good. Let's not uncoil anything just yet, because I got to get over there. Keep them deconflicted from each other.
How about that? Look.
Yeah, and then let's take 6 and 7 and tuck them back down and away. Great. And then whatever ones can be this little loop of 5 maybe up. And then the long tails of those long wire ties hanging down. We just tuck those back to the side a little bit. Push that tube 1 cut area there. Push that tube 1 area.
I got it.
That's great. All right.
Okay.
All right, Luca, we're ready to get you on your way.
Yes, ready.
This is AF right there at your helmet.
And Jessica, whenever you're ready, I'm ready for your motion.
Save us GoPro time. I'm going to turn your GoPro off for now.
You can leave it on. We have plenty of time.
Okay.
VLOS.
Are you there?
We are here with you. We're ready to come back to all zeros from the GCA.
Yep. We're ready.
Okay, copy. We'll put that in work. Okay, Luca, first thing I'm going to do is pull you out away from the work site.
Okay, copy.
Starting motion.
Motion.
Copy, continuing.
The voice you're hearing now is from Jessica Meir.
The next movement, we'll be taking out that pitch, so we'll be pitching you back.
Jessica Meir on the inside of the space station at the controls of the robotic arm. Luca Parmitano at the end of that robotic arm. She'll be working to maneuver Parmitano to the next work site now that the swaging of the 6 tubes at this work site is complete. They've already installed the pump and connected the 6 tubes here. You can see 2 of the other tubes dangling, number 4 and number 2. They'll work to route that to the nadir side, that's the opposite side.
Next, we're going to take out that roll, so I'll be...
And then from there, they'll work to start swaging on the other side of the space station.
Yeah, copy.
I can monitor that.
Pull the ingress aid towards your...
Yeah, the roll is not the issue anymore, Jessica. It's the pump, and I realize.
Confirm we concur, it'll be the boot plate to AMS. Starting that roll now.
Eyes on the clearance. Clearance is good.
Okay, Luca, next I'm going to be moving you body down.
Copy.
Okay, stand by, Jessica. So this one is one where clearance to the boot plate is an issue, so we're going to take a flip shot.
Okay, copy that. And ready for motion?
Promotion.
Okay, and just to confirm, Drew, body down meaning toward Luca's feet.
Copy.
Okay, starting motion.
Right, good motion and good clearance.
Copy.
Okay, give me a little lean forward. Okay, good clearance.
And Luca, now I'm going to be bringing you to your left.
Okay, and that's my shoulder to the pump. I'll lean back a little bit and you're clear.
Okay, starting motion.
From the helmet camera of Andrew Morgan, you can see Luca Parmitano at the end of the station's robotic arm, maneuvered by Jessica Meir at the hands of the controls for the station's robotic arm, maneuvering Parmitano to his new work site. On the other side, the nadir side, that's the side that faces the Earth, of the alpha magnetic spectrometer. There's 2 more tubes to continue this swaging process. They'll need to first route those 2 tubes that are still attached to the new pump system. They have a little bit of a longer reach, so they'll need to route it to the other side to make the connections there.
One more input for you. We're going to be taking out the rest of that roll.
Okay, copy.
Drew, again, that'll be the boot plate to AMS.
Copy.
Starting motion.
Motion, good clearance.
Copy.
Parmitano continuing to move on the end of the station's robotic arm as the space station passes 268 statute miles right over New Zealand into an orbital sunrise.
Okay, Luca, we are back to all zero, so give us a second to switch modes here, and then we will be doing a back-off maneuver.
Copy.
Okay, Luca, I'm going to be performing this last maneuver. It'll be moving you away from the work site, Stationator.
Copy.
Okay, starting motion.
Station Nader. Lean forward, Luca. Lean way forward. There you go. Good. That's good. Hold that. Okay, we're good. Good clearance. Watch your right elbow now. There you go. That's good. Good clearance. Far to go, Jeff.
Okay, we are at position hold now. Okay, and one more mode switch.
You're looking from the perspective of Andrew Morgan. He's helmet camera 18. You see at the bottom right of your screen there. Getting a good look at Luca Parmitano at the end of the station's robotic arm. Morgan helping Parmitano to position himself accurately as Mir continues to pull him out from his work site. Next movement will be a meter out.
Okay, starting motion.
Station half 1 meter. So yeah, push. Hang on 1 second, Jessica. I need to have you slide the swing arm back. Yeah, the swing. I can do it for you. All right, and then lean back just a touch. All right, tell me what in Luca's coordinate this is going to be, or the station coordinate. Do one more time, just so I can see the direction.
Mostly toward Luca's feet. It'll be station aft.
Okay, towards his feet. That way. Okay, just a little bit of a lean to your left, and then Jessica will have the clearance.
Okay, copy.
Okay. Yep.
How about that?
That's good.
Okay. All right, Jessica.
Okay, starting motion.
Push your light back in. Okay. Good motion, good clearances. Clearances are getting better.
Copy, Drew.
Luca, lean back a little bit. Show me your left arm.
A good view of Parmitano as he's getting pulled out from his work site where he swaged or connected 6 tubes. He's got 2 more to go. He'll be tilted a little bit downwards to position himself at the bottom of the alpha magnetic spectrometer and connect those last 2 tubes.
And then he is clear of ELC2, clear of AMS. You have a visual on him again?
Not completely, but we see most of him except for his head.
Okay. Yep.
Okay, Luca, we are ready for motion, and it'll be 1.5 minutes.
Copy.
Starting motion.
Okay, Drew, I think we can pick up some of the comm here. So the RET plus adjustable for caps 2 and 4. We want to stage that at the diagonal beam handrail. And then the next thing we can do is pick up the inventory of crew lock bag 3.
Okay, copy. Now, the two caps will end up back in crew lock back 3, is that right?
That's right, Drew.
The main caps. Okay. I'm thinking that maybe it'll be simpler if I just leave it attached to the, rather than stage it on the diagonal beam handrail. I could leave it attached to the bag. I think I'll be able to manage it if you guys are all right with that.
Bags are your thing. We wouldn't question you.
Okay, and then let's do the inventory on bag 3 when you're ready.
Hit it.
Okay.
Mission hold, Luca, getting set up for the next maneuver.
Copy. Okay, starting at the handle at the 12 o'clock position, I've got integral to an adjustable with cutting guides, and there is an extra small ret on there that we used to stage it on the diagonal beam handrails. And I have another integral to a cap keeper. On that cap keeper, I have 6 caps.
Luca, starting motion, 2 minutes course.
Copy.
From the helmet camera of Morgan, he's doing an inventory of his bag. You can see some of the caps, the more circular items there that were removed from the previous work of clean cutting the tubes and connecting them to the new pump system. Doing an inventory of that while Jessica Meir continues to maneuver Luca Parmitano to his new work site to swage or connect the remaining 2 tubes.
Small ret to an adjustable that's waiting to receive 2 and 4. On the outside, I have a small ret and a large small ret. So that's on you, Wade.
Yeah, sounds like we got everything large, small on the outside of the bag, you said?
Add a small, and a large, small.
Okay, so close all that up. Keep the adjustable on the ret outside the bag for caps 2 and 4, but then close everything else up and we won't have to inventory that bag again.
Position hold, Luca, we'll be loading the next JOCAS.
Copy.
Jessica Meir continuing to move Luca Parmitano at the end of the arm.
We were noticing more dropouts on Luca's comm than we're used to at the VSB worksite. We were wondering if it's a comm issue to the ground or if you were noticing the same thing.
Negative. I'm not, in terms of you're hearing garbled comm or your dropouts, I'm not experiencing that.
Okay, that's what we were looking for. Thanks.
Parmitano waiting for that next movement.
Starting motion, 3.5-minute JOCAS.
3.5.
That movement underway now. Luca Parmitano making his way to the next work site. In the meantime, while he's
Take a glove and hap check from you on your way to the work site.
While he's navigating to the next work site, keep sending in your questions using the hashtag AskNASA. This next one comes from Sonnet, who's asking that Luca Parmitano is at the end of the cannon arm, but how is Andrew Morgan getting around? Parmitano, being at the end of the robotic arm, has access to some of the best locations for doing some of the swaging techniques. Andrew Morgan was able to translate or move by hand over to a work site adjacent to Luca Parmitano. He has a bag in tow with many of the tools, and is essentially working as hand in hand with Luca Parmitano to give him the necessary tools, as Parmitano has the correct angle. There is a portable foot restraint that Andrew Morgan is using to allow him to use both of his hands.
Grab the tube behind it and not the AAF itself.
Copy.
Okay, Drew, next thing's for you. Go ahead, Drew.
Negative, go ahead.
Okay, so we're staging the following for the Nader worksite: the tool board, those cap keepers we talked about. Sounds like that's already taken care of. You're going to need your mini workstation RET for the plugs. We should have the same camera set up as before. We can use the GoPro on Luca. And then you wanted to talk about considering staging the MLI.
Yeah, I think that might be could be a good time to do that.
Okay, and then are you planning to roll your APFR to hotel?
Yep, I'm going to now. I just want to make sure I have the MLI with me when I do.
Yeah, okay. I think that's all we needed to get ready.
Okay, Luca, this is position hold. We're going to get switched over for a manual maneuver.
Copy.
And Drew will be expecting you to help us with clearances.
Okay, stand by then, Jess. I need to roll the APFR into position. Okay, I'm in position. So I'm ready for your GTA, ready for clearances for you, Jess.
Yeah, we're still getting set up for a manual maneuver, and we'll have 2 manual maneuvers before we start GTA.
Okay, roger. Be in position.
Luca Parmitano still at the end of the station's robotic arm. You see Andrew Morgan off to the side. He'll begin routing cables when Parmitano is in position. A few more movements to go. In the meantime, we'll continue to answer hashtag Ask NASA questions. This one comes from Nico, who's asking about checking Luca's gloves periodically and what other equipment needs to be looked at. You'll notice glove and hat checks throughout today's spacewalk. They'll continue to look at their gloves and inspect for any damage to the gloves. A lot of work, in fact, all of the work, done by the astronauts is done by the gloves. The HAP is a helmet absorption pad. In the event of a leak, it would be able to absorb water. But what they'll do is they'll report the integrity of the gloves, and then they'll say that their HAP is dry. In the meantime, Jessica Meir confirming that next movement of Luca Parmitano over to the worksite. From the helmet camera of Andrew Morgan, you can see his tool bag. There's a blanket that's on the end there. That is the Nader blanket. It's a multi-layer insulation that'll be used to cover the Nader worksite, or the worksite that they're going to now, which is on sort of the bottom of the Alpha Magnetic Spectrometer. They'll use that blanket to cover the worksite once their work is complete with the swaging. Again, 2 more tubes to swage or connect to the new pump system. Parmitano maneuvering to that position to work on those 2 tubes as we speak. A short handover in communications. As the tracking and data relay satellites, these are geosynchronous satellites.
To fly you back over to that last known Nader worksite.
We still have audio communication. Visual should be regained shortly. In the meantime, Jessica Meir continuing to move Luca Parmitano at the end of the Canadarm2 into position. The space station currently flying 264 statute miles over the South Pacific Ocean on a northeasterly course approaching the southern border of Peru. In the meantime, continue to send in questions using the hashtag AskNASA. You're getting a live look at the inside of the International Space Station Flight Control Room. Teams here led by Flight Director Emily Nelson. The voice you're hearing is Jeremy Hansen. The ground IV, he's the one here in the room relaying the information from the teams over to the 2 spacewalking astronauts today.
And we'll be tracking those clearances. None for you, Drew, but overall we'll always take anything you got for us.
Copy.
Okay, starting motion. Next, we're going to be going body up, about 15 centimeters, and Drew, for you, you'll be watching Luca to the AMS.
Yeah, copy. Say 15 centimeters. Okay, copy.
Okay, starting motion. Okay, there's the 15.
Okay.
Next maneuver will be pitching you down, Luca, about 14 degrees.
15 degrees, his head towards the Nader worksite, correct?
I'm pitching down toward the worksite.
Okay. Good at that? Yeah. Pitching down, all right. Yeah. I have the clearance here. AMS, pull your ingress data in a little bit. Okay, we're ready for motion when you are.
Starting motion.
Clearance is good. I got eyes on them all.
Copy. Okay, Luca, now I'm going to be bringing you body in 30 centimeters.
Copy.
How's your head alignment relative to the UMA cables there?
It looks good to me. I have, so this is the edge of my head. I have about 15, 20 centimeters.
Okay.
Okay, and you guys both ready for that?
Ready.
Ready.
Okay, starting motion. Okay, Luca, this is the position that you were in. Let us know if you need anything else.
Thank you. Looks like you're a little further than you were.
Yeah, I feel much further.
Okay, what do you think you need?
With the lane, I mean, go back to neutral again. I'll tell you, I estimate what, and pull the ingress aid in a little bit, and I'll look at its clearance relative to the radiator. Pull the ingress aid just a little bit. Yeah, okay. And then give me the hang loose measurement there with your hands. Yeah, okay. I would say if we can do body in 30 centimeters, I think that might help. What do you think?
And also a little bit of up.
Okay, up makes it, yeah, you can. Not as much though. I think maybe we could do 15 up, and then body in maybe another 30.
Well, can you teach me in, or is this going to make the arm release? Because if she can teach me in, and we can just go body up.
For our clearances, body in would be better.
Okay, then let's go body in and body up.
Okay, we'll start with body in, and was that about 30 centimeters, or are you reevaluating?
Yeah, 30 be good.
Okay, and Drew, you've got his clearance to AMS.
I have it. I have the clearances.
Okay, starting body in, and I'll give you 30. You can call stop early. Starting motion.
Parmitano and Morgan, the two spacewalking astronauts, working with Jessica Meir and Christina Cook on the inside of the station, working at the controls of the robotic arm, getting that precise angle for accessing the worksite. You can see one of the silver caps there. That's one of the tubes that they cut on the previous spacewalk to prepare for today's swaging activities. They'll repeat the same techniques that they used on the vertical support beam worksite to cut and swage these remaining two tubes.
Try for 10. You're going to need to lean toward me.
Okay, I'll take 10.
Copy 10. Starting motion, body up.
Just getting that precise angle. Once they do, that swaging will take place. Andrew Morgan routing those tubes over to where those silver caps are. They'll perform a clean cut, and then the swage, there'll be a particular fitting. Well, they'll fit the tube in with a nice clean cut and pinch them together to connect the carbon dioxide cooling tubes.
All right, Drew, you can grab those tubes and we'll route them down through the opening. Okay, reminder for you, Luca, another one about the loads into those tubes, so just to protect the ACC cables.
Copy.
And Luca and Drew, we had you routing both tubes at this time. As long as they're not going to be in your way, Luca, we'll try and get both of them through that passageway.
Do you have a preference, Luca, which?
What do you mean?
Which first? Or do you want both?
Just say to bust them both, but you can bust either one at a time. And
okay. The one I have in my hand first is 2.
Okay.
A little straight on it.
From the helmet camera of Andrew Morgan, you can see his position closer to the new pump box with all of the different tubes coming out. He's going to route tube number 2, which he has in his hand, and tube number 4 over to Luca Parmitano on the other side. You see him with the caps on the other side. He'll work to do the same thing that he did with the other 6 tubes. Prepare the alternate fitting, cut the tube, straighten it, mark it with tape, and then connect them together.
Better BRT position here.
These tubes allow carbon dioxide to flow through the alpha magnetic spectrometer and cool the system, which is collecting billions of particles, cosmic rays, and other particles from the cosmos. The cooling system is an added redundancy and an upgraded system that will allow the alpha magnetic spectrometer to continue to collect particles through the life of the International Space Station.
Tell me when you get eyes on
right now, you need to try to pull it. Okay, I got it number 2.
Okay. Tell me how much more slack you need me to feed out.
It's hard to say. Hold on. Actually, I'm gonna have you go on this side of the cable. Okay, this is gonna be good.
Okay. Yeah, a little bit more slack. And hold on, don't pull. So MLI is kind of near that cut tube 1, and I see it, and I'm clear of it, but I just want to make sure that MLI is not in contact with it.
That MLI is the multi-layer insulation, the white blanket around the tubes.
I could use some more. Yeah, this will do.
Okay, that's it.
This will do. Yeah, this is going to be good enough for.
Nearly 4 hours into today's spacewalk, routing the tube number 2 over to Luca Parmitano, currently in his hands. Tube number 4 will be coming next. Parmitano will perform the same techniques he used on the other side of the alpha magnetic spectrometer, preparing that alternate fitting you see at the end of the tube there, next to the cap. He'll clean cut the cap right off, of course attaching a tether to make sure it doesn't float away. He'll straighten it, mark it with tape, and then connect it to the tube, now routing tube number 4 over. With the tubes routed, Morgan will be able to reposition and hand Parmitano the necessary tools he needs.
Yeah, I'll make it work.
Currently in the hands with the with access from Drew Morgan.
I'm ready for the setup is good. I'm ready to start.
Okay, Luca. At some point, we got to get the rets on the caps, and then what we're planning to do is clean cut both of the tubes first, but you can prepare your first AAF. So whichever one you want to swage first, you can prepare that AAF.
We're going to start with number 2.
Okay. So you can open the MLI sleeve. We're going to need to ret to that plug.
And when I do these open, and for you, I have Bravo 7.
Bravo 7 is good, Luca. So ret to the plug, and then we'll need the wrench.
Do I ret to it myself, or do I wait for Drew to ret to it?
Yeah, I'm getting repositioned back to the HFR.
Take your time, Drew.
You're hearing Jeremy Hansen, who's here in Mission Control Houston, talking with the crew, working them through their procedures. Luca Parmitano is going to attach a tether to that alternate fitting. You see the rope at the very end of that tube there. He's going to attach a tether there and work to prepare that alternate fitting. Then he'll clean cut both the tubes, prepare the other alternate fitting, and join all the tubes together.
Some lacing cord, and it ultimately got away from me. All right, so I'm ready for
ret.
This is the ret for the cat.
Yeah,
Okay.
Ret for the plug.
Oh, ret for the yeah.
AAS plug.
I have ret for the plug, so I'm ready to the plug.
Now I need 7/8. It will pass you my ret.
Okay, Drew, the next is...
7/8 before the street.
Yeah, next is the wrench.
And I'm ready to the 7/8.
Same, your 7/8.
And now I need the strainer. I'll ret it I want to.
You have red on the straightener. Okay, straightener's you.
Good. Alright, I'm ready to remove the plug.
Okay, Luca, your go. See, you're using the wrench.
It's on.
Oh, I got these tucked away.
Okay, the plug is away. Closing the VLI. One turn. The side. And I still have Bravo 7.
Okay, good words, Luca. Next, we're going to ret to the caps, Drew.
Luca, which cap do you think you'll cut first?
I've got number 2 first, because that's what I just thought.
Okay, if you would put this hook onto cap number 2.
Okay, let me...
Now, the technique that we used was just putting it on both of them at the same time.
And then this other hook will go to 4.
Alright.
I had to reopen bag 4 bag 3. So I don't know if that means that we have to inventory it again, but to open, I'm adding 2 plugs in the case.
Alright, so next is the clean counter.
I'll let you know, Drew.
Luca, we probably can give you a little bit more pitch, too, if you do need it.
I'll let you know. Right now, I'm still good.
Morgan handing off the clean cutter tool. Now that a tether is attached to the caps, They can cut the caps without them floating away. This clean cutter will allow a very even, clean cut around the tubes without any bending of the tube itself to allow good flow of carbon dioxide for the cooling of alpha magnetic spectrometer.
Okay, Drew, we are going to grab an inventory on that bag just to double check. You probably got time now while Luke is clean cutting if you want.
Well, let's say we just inventoried bag 3. I'm suggesting that we wait, and I was asking if we need to do it after I get these 2 plugs and caps.
Yeah. So if you basically, Drew, you can do it as if you inventory it, then keep it under control while you just add the 2 caps. That's considered an inventory complete. But since everything got let out of the bag, then we are going to do a full inventory. But we're happy waiting until we got the caps in there, and we're doing good on timeline, so we'll have the time for the inventory.
Roger.
Next for you, Drew, is tape. And next, the other thing I need from you, Drew, is a glove and half check.
Copy. Half is dry. And no change, intact. And if I got it back, thanks. Right, tube 4, or cap 2 is contained on the adjustable.
Do you want me to cap number 4 as well before I straighten them?
Yes, that's the technique. But if you have another way you want to do it, Luca, there's no problem. But that's what we were planning to do.
Okay, no, let's do that. Wait. Need a straightener again, Drew. Oh, yeah. Been working, sorry.
The clean cutter, right?
Sorry, the clean cutter, yeah.
So the only thing here is we got to make sure it's not super critical, but we want to not mix up these tubes, Luca. Once we clean cut it, we're not going to have any indicator of what's what.
Yeah, Luca,
I almost want to do it standard, Jeremy.
There's no issue with that. However, what we did notice in training was that when you try to clean cut with the AAF attached to that other tube, it can be quite cumbersome. And as we know, we can back out of, if we do swap out the tubes, we can back out of it by some changes in the pump box.
All right. These 2, Drew. These 1 down, these Drew, these 2, these 1 out, these 4. Okay?
Yep.
Yep. Okay, we got one more idea, Luca. If you want to straighten and tape, you can do that before you swage if you want to mark the tube.
That's a good idea, and then we'll have a serial number to correlate.
Yeah.
All right, so well, let's take the clean cutter off of tube 4.
Actually, why? I like you there.
Okay, and you have the tube straightener with you.
Yeah. Working it right now.
So right now, Parmitano working to straighten and measure the tube. He'll mark that tube with tape so that they don't lose track of which tube is which. The bottom being tube number 4, or the bottom being tube number 2, and the top being tube number 4. Once they're marked Parmitano will complete the clean cutting of tube number 4, and then they'll attach the alternate fittings to complete the swaging or the connection of the tubes to the new pump system.
Yes.
All the way to the window?
Yeah.
Right. Okay.
Okay.
Okay. So, Luca, this one's serial number that we're putting on tube 2, the serial number 13. And I think this one goes out to all the flight control teams that have been sitting console for these EVAs.
Ah, nice. Nice. Okay, number 2. Number 2. Your number 13.
3.
Okay, Luca.
Reed, if you can help us keep track of that.
We got it.
Tube number 2 has been successfully marked with the tape. Each of the pieces of tape are marked with a serial number, and each of the serial numbers are associated with members of the team who contributed to the hard work going into today's spacewalk, and the whole series of spacewalks dedicated to the repair of the alpha magnetic spectrometer.
4.
With tube number 2 marked successfully,
I just didn't see
Parmitano will move on to clean cutting tube number 4.
No, but you got it. You're way ahead of me.
No change. What close am I for these bricks?
Or the left side of your helmet has a little bit of contact. Yeah. That's 2 and 4 to me. And we should be complete with the clean cutter. Yeah, 2 and 4 to me, rather.
Hey, Luca, let's go ahead and finish tube 2. You can verify the tape with the straightener, and then we'll put the AAF on.
Or straight in tube 4.
That's just our preference. If you have a strong feeling, let us know.
Well, I think, straightening this tube with the once the number 2 is connected, it's going to be just as hard as cutting it.
Okay. Yeah, we'll go with it. Keep going. You're good.
careful not to mess with number 2.
So that's it for the clean cutter, doing its job successfully, cutting all 8 tubes. Now Parmitano working to straighten and to measure tube number 4. He'll mark it with some tape and then finish up the swaging for the last 2 of 8 tubes. Swaging being the connection of these tubes, pinching them together to allow the flow of carbon dioxide through the cooling system.
And through the window, yeah.
Nice. These weren't nearly as onerous as we thought they might be.
Good job, Luca.
Right. And Luca, this good-looking one here, 17. And this one's for the AMS team that has been working on this for the last 4 years.
Yeah. Good one. Okay, 17 is tube number 4.
Okay, 17,
All
Luca.
the AMS teams. Andrew, you can take the strainer.
Yeah.
Hang on, Luca. Double check that before you give that back, Luca.
All right. You know what? Yeah, I'm going to do that. I'm going to do the outside. Okay, number 2 is on the edge. And number 4 is also right on the edge.
Okay. And just keep that straightener, so we'll double check it once more before we do 4, Luca. There's no harm in being sure.
Okay.
Okay.
Okay, we're starting with AS number 2. I have Bravo 7 for AS2.
Okay, it's a good number. Your go to insert it should be tape 13 going to tube 2.
13,
Right.
tube 2.
Yep, and I can confirm as well.
And this one is, okay, now we're talking. Okay, I managed to push it all the way about little over a quarter of an inch from the VLI, but definitely way past the black line.
Okay, that's good, Luca.
Okay.
Let's double check the number and then swage it. Actually,
I have Bravo 7. Bravo 7.
okay. All right, 1 turn on that. Keep an eye on the tape.
Keep an eye on the tape. The tape ain't gonna move. Okay, I have good rotation, no motion on the tape. For Bravo 7. I have Bravo 7. I have a good pull test. Oh, wait, hold on. Okay, yeah, good pull test. The highlight kind of slippery. And going for VLI, I think.
Yep. You got everyone's attention there with that call. You are go to tighten the VLI, cycle the cap.
Look, I'm ready with the camera.
Good VLI. check. And okay, making sure. Okay, making a video. Survey. Looking to VLI.
And Luca,
handle.
just make sure on that VLI you tighten it to a high torque value by hand.
When I say tighten, it's as tight as I can get it. Maybe.
Yep, no problem.
I don't know what torque you expect. It's.
No, it's just sometimes when we're watching
Okay.
in the WVS, we just can't tell how much effort you're putting into it, and we just want to double check. We trust you.
Copy. It's as fast as I can.
Yeah, no, that's good. And I think you got the closeout photos, so you can cover it up. And we'll move on to 4.
This is Mission Control Houston, switching over from satellites, the tracking and data relay satellites that provide video and audio communication, regaining some of the audio communication now. The 7th of 8 tubes now swaged or connected to the new pump system. Parmitano now working on that last one. He needs to go back and remove the cap from the alternate fitting before actually putting the tube into the alternate fitting.
For the plug. Plug. Plug.
Tube number 4 will be the final tube to swage or connect.
Hold on, Drew.
Okay, it's caught up here somewhere punching.
Yeah, so always gets caught. Still caught in the same place.
It looks like let's pull it back a little bit, and then rotate it. And go visor up, and going down.
Parmitano and Morgan working together to remove the cover from that final tube. Underneath the cover is that alternate fitting that'll eventually be mated to the tube which has already been cut. tube number 4. That's the last tube in this series of 8. In the meantime, the space station itself, 263 statute miles over the eastern border of Ukraine, entering into an orbital nighttime.
Sort of punching going on here.
So what we have done on that one, Drew, is shove the tube straightener down there as well, or the wrench actually. Wrench is the other tool we've used. You just push it down to the MLI, past the AAF, and sometimes helps that go.
There's like a, this much. Still getting, and turn it toward me while you do that. Let's see if it looks so. Yeah, we got a big bunch up there. Yeah. I'm not able to get the wrench past it. It's almost like there's a blind pouch. Let me try from up here. Yeah, I see what you're saying. There's some bunched up, but even the wrench is not going in. Let's back it all the way. I'll give it all the slack. Is it moving freely after that point? It's trying now. Easy. You keep the tension. No, keep the tension. Yeah, we're making it. Getting that. There we go. There it goes. All right. Now we can put red. Okay, there's a red on the plug. All right. The wrench back to you. Yeah, we can let go.
And with a little teamwork, exposing that alternate fitting that'll eventually be mated to the tube, which has already been clean cut and is ready.
What do you got for numbers, Luca?
The numbers, I have Echo 8.
Echo 8 is good.
I see the double line on Foxtrot 7.
Okay. Those are both good, Luca. All right, I see you using the wrench to stabilize it. You can open the VLI.
VLI is the visual leak indicator. Will be used on the next spacewalk to check all of the tubes and make sure that carbon dioxide is flowing nicely through all of the tubes and that they're successfully swaged or connected. The swaging process is using that wrench to turn the bolt that's on the inside of that alternate fitting and pinch the tubes that have been cut to mate them to the new pump system.
Beam handrail tether point.
And got it staged on the diagonal hand beam. Plug is out.
And Jeremy, this is just like the second one that I did. I have tiny rotation towards loosening on the main handle. So, I mean, still Foxtrot 7, just rotated maybe 1/16th of a turn.
Okay, that's good, Luca.
And the tube is all the way in. I have Delta 1 in front of me. I think corresponds to the same position.
It does. Delta 1 is good.
Okay, so I'm going to go start working with eyes on tape.
Yep.
I'm going to go towards Delta 1.
Okay, good words, Luca. We cannot see the tape, so it's all you. You're going to have to watch it yourself.
I have the tape in front of me. And as I start the motion, as I start diving in, you see no motion on the tape. I'm looking for Echo 1, is that what I said?
Delta 1.
Delta 1, okay.
Delta 1 or Echo 8. Luca, how far was the tape from the end of the VLI handle? I missed it.
1/4 of an inch, and I still have 1/4 of an inch. I have Delta 1, and I'm ready for the tool test.
Okay, good words.
And I have a good tool test.
All right, you can tighten the VLI,
Type
cycle the cap.
VLI.
Drew, what about you? Are you ready to put down that hook A?
Okay, down.
Okay, once hook A is down, then you can remove the long wire tie.
Just getting the... A rat to the wire tie.
And Luca, just call it the cap cycle. We couldn't see it.
Realize this. Cap cycle and good and VLI as fast as I can. Delta 1 equal 8. Closing the air handle.
Done, Luca.
All right.
I'm going for the MLI.
Okay, and do you want to take a quick photo of that one, Luca? 8 for 8. Great work.
Yeah.
Let me give you a GoPro.
Say again, Drew.
I was going to hand him my GoPro.
Yep.
Do you see it? Where's that red going?
All the way down.
Down where?
It's on your it's somehow caught on your waist center.
My waist center.
Towards your seat, towards your it's the Velcro. The Velcro caught on your leg.
On my leg.
Right there. Got it.
Wow.
Yeah, the Velcro the bracket.
Okay.
If you can, you will.
Did.
There it goes. It's a light, Delta 1. Okay, Drew, here comes your camera.
Okay, shoot a bunch of stills too while I get situated with this.
Okay, put it to work.
Before you do the stills, Luca, you might as well finish up the MLI. What's key here is, in addition to using the MLI on the AAFs, is to try and tuck the previous MLI you opened up last EVA, just to make sure that none of the Mylar is exposed. And there's two, you remember there were two Velcro tabs on that MLI? You can try to use those. Ideally, they would be Velcro back together.
I will. I'll try. Okay, now to do this a little more easily, I probably want to give back the tools so that I have a little bit more accessibility. Drew, if you can take back the 7-8. And also the...
Ground IV Jeremy Hansen spending a significant amount of time training in spacesuits on the ground, performing some of the tasks that Luca Parmitano and Andrew Morgan are undergoing right now, understands the delicate procedures, just making sure that all the different components are covered by the different blankets. Those are the MLI multi-layer insulations. This includes the tubes themselves, covering the alternate fittings that are ultimately connecting those tubes to the new pump system, and then the cover themselves.
You. Back to me. All right. Okay, now I'm going to reposition the tube so I can try and close that MLI.
And if it helps, Luca, Drew can pull those tubes back.
On your black back, Luca?
No, it's going to be as covered as it's going to get. Do you guys have WVS?
Yeah, it looks pretty good, Luca. So next thing for you, Luca, is to work the nadir blanket with Drew's help.
A weed for accounting that long tie and the wet that was associated with it are going on the lid in the green bag. The lid of the green bag, that's a ret in the water tie. I know we got a specific place for it, but that's best for it for now.
Okay, that's great.
Okay, it's down, and I'm handing hook B here. I think Luca, the suit, hook B goes on.
Yeah, hook B is for you, Drew. Ideally, you're going to get that one. And then Luca can do hook C. And just a reminder while we're in here, let's watch for the sensitive points.
Roger.
Andrew Morgan and Luca Parmitano working on one of the get-ahead tasks, installing a blanket on the very bottom or the nadir side. This is the Earth-facing side of the alpha magnetic spectrometer. All the tasks, the primary tasks for today, have been complete. Installing the pump, connecting and swaging all of the tubes, including the tubes on the very bottom where they are now, accessing the nadir work site, the bottom work site, and swaging or connecting those last two tubes at the bottom, all checked out. Now this next part will be installing this blanket. This is one of the get-ahead tasks for today, now just 4 hours, 40 minutes into today's spacewalk. The cleanup activities, though, will take some time to get ready to go into the hatch. This includes getting Luca Parmitano back to the hatch via the Canadarm2 and cleaning up all the different parts of the alpha magnetic spectrometer. The next spacewalk will be dedicated to leak checks for all of the tubes that have thus far been connected, all 8 of them, and cleaning up the alpha magnetic spectrometer itself, powering up and beginning to collect data once again.
About 1 meter to my right.
Well, your ingress aid toward you.
See that, Luca? And last time it was almost 1.5 meters from where you are now. Do you want to just start with 1 meter?
No, I thought that it was 1 meter. If it's 1.5 meters, whatever I drove you last time, that's what I need to do.
Okay, I'll take you to that position, and you can call the stop early if you need it.
By on that movement, Jessica, I just want to say, so we're good with that amount of loop protruding? I mean, we want to make sure that the MLI is going to cover that?
Yeah, I'm not sure what the question is, Drew. It looks pretty good from the WVS we see.
I'm talking to Luke. Yep, okay. Right, Jessica, over to you.
Okay, starting motion to your right.
Motion.
Copy, continuing.
Jeremy, while we're doing, oh, never mind. Continue motion.
Copy. .25 centimeters to go.
Continue.
Okay, Luca, this is that right position. How does that look?
Be very tight.
And again, Luca?
It's NGCA.
Copy, GCA complete.
All right.
Yeah, I found the strut. It's making the foot go behind it. Alright.
Just watch your WVS there,
That
Luca.
worked. Here. Okay.
Place.
Okay, looks like nadir blanket is complete. I can take a closeout photo of that side if you can get it, Luca, and then I think we're ready to start sending you home.
I confirm you're not going to pull the maps up today?
Say again, Luca?
What about the maps up?
Checking.
Can you give me some light on that end?
Yeah.
And Jeremy, the next thing I was going to tell you is that at one point I noticed that my right helmet light was touching one of the UMA cables. I don't know if you guys have an easy, quick way to check that there was no, there's no issue, but I just wanted to let you guys know.
Okay, checking, Luca.
And I can see if it both looks fine.
Okay, so big picture, Drew and Luca, we're in good shape here. We got everything done that we plan to get done, and then some. So at this point, we're going to be heading back so we can clean up the arm and get back inside. There's nothing we need to do with the mud flap that adds value to today's spacewalk. So I think we're all good there. The only question remaining is whether Drew needs any help from Luca getting stuff in the bag, or if he needs Luca to take anything back before we start you back to ESP2.
I'm glad to help.
I mean, we can, at this point, the best thing would be to make sure that Luke has plenty of time to get the arm. I'm sure I can get this all in there. It'll take just a little bit of, it'll take a little time, but we'll get it all in.
you are the bag master, and we have plenty of pad. We could probably make 2 trips. So with that, Drew, you can start tidying up, and we'll give Luca the comm to get himself heading back to the airlock. And then.
Okay, and I just want to say I got eyes on the UMA cable now that Luca was talking about, and I mean they look exactly like they did. They look fine, and the levers are forward, and everything they look great. I took some quick GoPro of it too, just so we can be sure.
Okay, and Luca, you were asking about AMS health.
And Drew, before you get busy with bags.
Wonderful. Glad to hear that.
Okay, guys, so the first thing we're going to do, and Drew, before you get busy with bags, we're going to take out the pitch. So we're going to pitch Luca back, and then we will take him back to the left.
Okay, copy. Luca, ingress 8 towards you, and that will clear your tether away from the radiator. Are you good?
Okay, here comes the pitch motion.
Okay, that's good motion, and the clearances are good.
Copy.
Stop motion.
Copy.
Okay. How much further are we going in that direction?
We have 8 more degrees.
You're pitching forward.
Negative, pitching back.
Okay. Okay, continue.
Okay, continuing.
Luca, pull on the ingress 8 a little further. That's great.
So a quick recap of what's been discussed and performed so far. Luca Parmitano and Andrew Morgan way ahead of the timeline. Clean cutting and swaging all 8 tubes. Getting a get-ahead task out of the way, installing the blanket on the bottom or the Earth-facing side of the alpha magnetic spectrometer. Now beginning some of the cleanup activities.
Okay, you ready for that?
Working with Jessica Meir inside the International Space Station, working the robotic arm. Going to maneuver Luca Parmitano, who's currently positioned at the end of the robotic arm, back over to the work site to exit from the foot restraint currently holding him in and get back into the hatch. In the meantime, Andrew Morgan going to clean up the work site, get all his tools back in the bag, and head back over to the work site. 4 hours, 50 minutes into today's spacewalk. All major tasks and a get-ahead task complete, now going through the cleanup activities.
Our settings here, and then we're going to do a manual maneuver.
Okay.
Okay, Luca, we are going to start this motion. It's going to be taking you about 1.5 meters station aft.
Okay, copy.
Okay, starting motion.
Back. And your good motion, good clearance. And getting better. This is getting better and better. Yep. Good clearance. Jessica is well clear of the work site.
Okay, thanks, Drew.
Okay.
Okay, Luca, now we're going to be bringing you Station Zenith.
Copy. All right, Drew, I'll see you back at the ASP, I suppose.
Yep.
Okay, starting motion.
Copy.
It's actually Station Nader, but it's a short movement now.
Okay, later.
Okay, Luca, we are going to now load a JOCAS.
Yo.
Okay, Drew. Where do you want to pick up? How about crew lock bag 3?
Yeah. I'm going to tell you that there are 8 caps and 8 plugs here, and I can see the 2 cutting guides. Connected by an adjustable. And a large small on the outside and a small small. The 6 adjustables on the cap keeper.
Okay, that sounds like a good
Am I missing anything?
No, I don't think you are. I'll get a double check from the ground team. Okay, Drew, it's a good inventory. You can close up bag 3. I need a glove and hap check from both you and Luca when you can.
So drop that from Lucas Gloves. I have.
Luca, starting JOCAS 3.5 minutes.
Copy.
Okay, gloves look great, pristine. I don't see anything, and the hap is dry.
Okay, copy, Drew. All right, next I've got trash bag to crew lock bag 4. But you can call this stuff out in any order you want to do it.
Yeah, I'm going to just start working my way back to the bag. Stand by, I got to reposition the HFO.
Luca, that's position hold. We're going to load the next showcast.
Copy.
Nearly 5 hours into today's spacewalk, you're getting a view of Luca Parmitano at the end of the station's robotic arm. Jessica Meir at the controls of the arm, maneuvering it slowly but surely back to ESP2. This is where Luca Parmitano originally entered into the foot restraint at the end of the robotic arm. The same position will be used for exiting the station's robotic arm. All activities today have been completed, even a little bit ahead of schedule. All 8 of the tubes were clean cut and swaged or connected to the new pump unit that was installed onto the alpha magnetic spectrometer. They even got a get-ahead task out of the way, installing a blanket underneath the alpha magnetic spectrometer.
Okay, we do not need an inventory on that one if you didn't open it.
Copy, thanks. So the inventory will be Krulak back 4 if you are ready for that.
Go for it.
Okay, on the exterior of Krulak back 4, I have 2 wire ties. I've got a large, small. I now have the trash bag from the major vacuum case handrail with its associated small red to the Krulak bag.
Copy.
To an integral, I have a cap keeper with the 4 caps. Wait a minute, I'm counting 4 caps. And then to an integral, I have the wire tie caddy with all of its wires. I've never used one out of there today.
Okay, good config on Krulak bag 4, Drew. And just so the 2 of you know, we're probably going to have a long KU outage here, but we'll have you on Space to Ground 1.
Copy.
Another handover of satellite communication, the tracking and data relay satellites that are positioned in geosynchronous orbit around the Earth, providing video and audio communications from the International Space Station. We'll keep maintaining those audio communications, but as noted from Ground IV Jeremy Hansen, this will be one of the longer outages for video from the International Space Station, expected about between 20 and 30 minutes. In the meantime, Luca Parmitano still making his way over to exit from the foot restraint that's currently holding him in. We may be regaining video communications in and out throughout that time, but it will be a longer outage.
We transfer red. I thought maybe that one goes into the lid of the red bag, but remind me.
Getting some video from the station as the space station itself passes 268 statute miles, entering into an orbital sunrise just off the southeastern border of Australia.
Only if you remember, we'll find it in the...
Sorry, your next showcast, 3 minutes.
At the time that I handed off to Luca, it stayed with the bag because we used this PGT rip as the second rip for the GoPro.
Starting the next showcast, 3 minutes in course.
That work weed or did you dig further?
Yeah, it's just I'm not sure what you're telling me is there a ret? It's supposed to be an extra ret in crew lock bag 4 from the GoPro, or did it end up somewhere else? Did it end up with the PGP instead?
Negative. I'm going to just confirm that it is in crew lock bag 4. That is where I believed that I left it, but let me check.
I remember you put me there, though. Or actually leaving it there.
Yeah. Okay, I see it. There's an empty, small ret on the same side as the wire tie caddy and crew lock bag 4. That's the one that went out with it and never went to Luca.
Yep. Okay, that makes
associated with
sense.
The GoPro.
Yep. Okay. Mystery solved.
As Parmitano makes his way by robotic arm back to the external platform near the airlock so he can exit from the foot restraint, Andrew Morgan doing an inventory check, as he was the master of all the tools and equipment brought out to the work site for Luca Parmitano to access
Go ahead.
from his great vantage point at the end of the robotic arm. This is part of the cleanup activities. Both spacewalkers completed all of their primary tasks, now just cleaning up from the work site and preparing to enter back into the Quest airlock for repressurization and to complete today's spacewalk.
Clean cutter, both those items redded to their respective reps. The 7/8, the empty integral rough cutter to its tether point. We have 1, 2, 3, 4, 5 remaining pieces of tape.
Okay, Drew, and can you just verify the head is closed on the clean cutter?
Okay, Luca, position hold, and position hold, loading the next showcast.
Okay.
The head is closed.
Okay, it's good inventory.
I'm going to put that on just because it's the one I grabbed, hook 3 into a red bag. And then I'll give you a red bag inventory, and we'll close it up. On the lid is the, strike that. Let me go back to the beginning here. The exterior of the red bag is 2 large small adjustables and a large small ret. The large small ret I know will need to go to the interior, and I'll take a reminder before I leave, and I'll verify when I put that inside the bag. Inside the bag, that small, that is the transfer ret on the lid.
Luca, starting next showcast, 3.5 minutes.
Copy.
Then I have a fish stringer, and on the fish stringer is the inventory tool board and inspection mirror. Stowed in the red bag lid right now is the AAF blanket.
Okay, Drew, I'm back with you. I missed that. The last thing you were talking about was what was on the lid.
What parts of the red bag inventory are missing, I guess, is a better...
So we're expecting one more ret on the fish stringer. Okay, 2 small rets that are empty.
2 small rets that are empty in the red bag?
A-firm. One's a transfer ret, and then one was just a small on the fish stringer.
Okay. The transfer ret is on the lid of the red bag. What was the? Because I don't have another small in the fish stringer in the red bag. What was that associated with?
So it was the Nader tube clip that was on the lid of the bag previously.
Okay, I just transferred the MLI blanket, the AAF blanket over to the green bag on that red.
Okay, that works. Red bag's good. Other than moving the large-small ret inside, you can close it up.
Five hours, 9 minutes into today's spacewalk, in the middle of a handover of some of the video communications from the International Space Station. This is one of the longer ones, expected about 10 more minutes before we start acquiring views again. In the meantime, Andrew Morgan continuing to go through his inventory. He brought all the tools out to the worksite and aided Luca Parmitano, who had access to all the right connections and tubes for all of the activities today. Just making sure everything's in order before he heads back to the Quest airlock for entering back into the space station. Luca Parmitano, in the meantime, being guided by the robotic arm. Jessica Meir at the controls of the robotic arm inside the International Space Station, guiding him back so that he can exit from his foot restraint and go back into the Quest airlock and complete their tasks for today. As we wait for some of the video to come back from the International Space Station, please keep sending in questions using the hashtag AskNASA. We'll try to answer as many as we can.
Okay, for the green bag, I think every crew lock bag on the inside is inventoried, so we can go inventory green bag now.
Okay, go ahead.
Andrew Morgan continuing to work through his inventory. In the meantime, please use hashtag AskNASA for questions. This one comes from Kate. Will there be a total of 4 spacewalks as planned, or are there going to be more added to the series to make sure the unit is fully functional again? Now, the new pump box has been installed. Checkouts of the power were underway, and everything's looking good for the new box and the alpha magnetic spectrometer. They still need to boot up the alpha magnetic spectrometer, but first they need to complete one more spacewalk, and that's to check some of the tubes that they connected, ensure there's no leaks, that each of the tubes that were swaged were properly connected, and that there's no additional leaks. Now, coming up here soon, we have a launch of a cargo vehicle, the SpaceX CRS-19, the Dragon vehicle, bringing up more science and cargo to the International Space Station. Some of the science is critical, and we'll be launching here Wednesday, December 4th, for a launch at 12:51 p.m. Eastern, 11:51 a.m. Central.
That's all good, Drew.
That will be launching cargo to the International Space Station, more than 5,700 pounds worth. Once the cargo vehicle successfully arrives to the International Space Station containing time-sensitive and critical cargo, the space station program will assess a future date for the alpha magnetic spectrometer spacewalk to wrap up the procedures, check those leaks, and power the alpha magnetic spectrometer up. In the meantime, the alpha magnetic spectrometer will remain in a dormant state, completely safe and ready for those leak checks. Then once they're performed and All the scientists and engineers can confirm that the spacewalks and swaging techniques and the new pump box all are operating nominally. They'll power the alpha magnetic spectrometer on so it can continue to collect great science, analyzing billions of particles and looking for the origins of the universe.
Okay, Drew, looks like I'm back with you.
Yeah, the wire, there's a long wire tie and ret on the lid as well. Sorry, I missed that.
Okay, and the other thing was the adjustable that was on the PGT. Did Luke end up using that or for his fair lead at ESP2?
Negative. He used one, but there is still an adjustable on the handle of the PGT.
Okay, PGT has
I didn't know he used an adjustable.
Okay, all right. So we got the adjustable 7/16 socket and the PGT. That's a good inventory. You can wrap that one up.
It's all going to fit.
Cleanup activities still underway as we await for regaining that video communication from the space station.
Comes the last JoeCast, 1.5 minutes. In motion.
The arm's still maneuvering Luca Parmitano back to the external platform near the airlock so that Parmitano can exit from the foot restraint currently holding him to the Canadarm2. While we wait for some of those video communications to come back, keep sending in questions using the hashtag AskNASA.
So a reminder, Drew, on the red bag, when you get back to it, we need the straps to the lower tether points, and we still got to pick up the large, small ret on that red bag, and then you're bringing the green bag back with you.
Roger.
You'll hear ret being used quite a bit for the inventory that Andrew Morgan is currently undergoing. That's a retractable equipment tether. It was used very frequently throughout today's activities to make sure that all of the components that were being worked on by the two spacewalking astronauts were secured by a tether, a cable basically connecting each of these components to the astronauts themselves, making sure nothing's floating away. While Morgan continues to go through the inventory and Parmitano is navigated back to the external platform just near the Quest airlock, keep sending in those questions. This next one comes from Linda. Linda is asking how fast the electric arm moves the astronauts. This is in reference to the Canadarm2. This is from Mrs. Purnell's 4th grade class. A very good question. The robotic arm, this Canadarm2, does move very slowly, and that is for a very specific purpose. The slower, the better. That really is the technique. Moving too fast may cause unnecessary additional movements, something called oscillation of the arm. It means if you were to move and then suddenly stop, the arm itself would shake. Now that would put the astronaut and some of the structure of the International Space Station in danger. So the slower the better.
You're ready. We're going to bring you to the ESP2 egress position. That's going to bring you station aft toward ESP2 about 1.5 meters.
Copy. I'm ready.
And Jessica,
Okay, starting motion.
just one more thing.
And this would explain the incremental movements as well by Jessica Meir,
Do a good sweep to make sure we
moving Luca Parmitano back over to that external platform.
over to you, Jessica.
Okay, Lucas, starting motion.
Motion.
Okay, continuing. There we go.
You're getting a look at the inside of the International Space Station Flight Control Room at the Mission Control Center in Houston, Texas. Teams here are of the Orbit 2 team, led by Flight Director Emily Nilsson. She's overseeing all of the teams looking after the systems of the International Space Station. You're hearing Jessica Meir on board the International Space Station, but you also might be hearing Jeremy Hansen. 2 spaces over from Emily Nilsson. Jeremy Hansen, Canadian Space Agency astronaut, has spent a significant amount of time in some of the training and mock-ups for the Alpha Magnetic Spectrometer spacewalks. He himself suiting up on some of the ground units and training for these intricate procedures, able to guide the 2 spacewalking astronauts through some of the finer details of what it takes to successfully conduct these maneuvers. And successfully so, as all of the primary tasks, as well as a get-ahead task, have been completed for today. Today being one of the more complicated spacewalks of the Alpha Magnetic Spectrometer repair.
GCA complete. Stand by.
Next to Hansen, Ricky Arnold, the Capcom for today, communicating with the astronauts on the inside of the International Space Station.
Okay, Luca. So for you, you can basically start cleanup of the arm at this point and your tether swap. And since Drew's not back yet, you can probably plan on just translating both up and down the CETA spur.
Okay, so confirm that I'm going to clean up the arm, meaning I'm going to deconfigure it, take first the AGFR, then store it somewhere, and then take the width extender.
Yeah, and they're both going back to the airlock. I don't know. You don't need to go up and down the CETA spur, obviously. That was the previous EVA. You're at ESP2.
Right, so can I translate with both the AGFR attached to the width extender, or is that not possible?
What I understand, Luca, is that you're allowed to do it, but people have said it's hard to make the adjustments on the APFR when it's on the end of the width extender, and you're going to need to reconfigure it for stowage. It's up to you, though, how you want to do it.
Okay, so either way, I'm coming back. I'm doing a couple of tricks, is that right?
No, that's not right. You could, you just need to reconfigure the APFR settings and the width extender settings before they get left in their stowage location on the airlock. So you could do that at the arm right now, you could do it down at the airlock, and you could translate with both of them together on your BRT. It's personal preference.
Okay. Yeah. Understood. Lead. I'm using that adjustable from my Fairlead to keep red bag tacked down.
Copy that, Drew.
Regaining that video communication from the International Space Station, you can see Luca Parmitano has been successfully navigated to that external platform.
Okay.
Has exited from that foot restraint holding him into the Canadarm2.
Okay, you're doing your tether swap.
And is reconfiguring his tethers to make sure his journey back to the Quest airlock will be a safe one.
And we're 5 hours, 23 minutes in on this EVA. Looking good.
Luca Parmitano, EV1, lead spacewalker for today, the suit in the red stripes. Reconfiguring his tether as the International Space Station passes 262 statute miles over the South Pacific Ocean on a northeasterly course.
Okay, copy that, Luca. Reel's unlocked.
The reel is unlocked. Okay, now in order to deconfigure the arm, I'm going to need to GCA it.
Yeah, Luca, we were expecting that. We have another position to bring you for the APFR config, and it brings you back to where you started before. Basically, that brings you station zenith emitter and then brings you port emitter.
Okay, I think that will be fine with just a zenith motion for now. And then I will let you know if I need any more.
Okay, so stand by. I'm going to take the brakes off and get into mode. And Luca, so you just would like the zenith motion. Would you like that full meter?
Go ahead and I'll guide you more if I need it.
Okay, copy that. I will bring you 1 meter zenith. And Luca, can you clear the ingress aid that's behind you?
Ingress aid?
Stay firm. It may just be parallax, but we can see the ingress aid behind your back.
Yep, the ingress aid behind my back. So I'm currently, my back is to the...
Yeah, Luca, we've cleared it now. We've cleared it with another camera view, so we're good. I'll continue motion.
Jessica Meir at the controls of the robotic arm, maneuvering that ingress aid, the portable foot restraint at the end of the robotic arm there. Maneuvering in a position so Luca Parmitano can retrieve his tether, currently attached to the Canadarm2, where he has been for the entire duration of today's spacewalk. Just undoing that tether so he can make his way back to the airlock and complete today's spacewalk.
Okay, another 1515 zenith.
Basically 50.
50 zenith, copy.
That large small red is inside the red bag. The tether points are to the bottom tether points.
Copy.
There you go, Luca.
Okay, GCA complete.
Copy, GCA complete. So that will be all you'll need for today. I'll bring the brakes on.
Brakes on.
The brakes coming on.
Okay, Luca.
And the brakes are on. You are go for APFR config.
Luca, if you're going to do the all-in-one, then you might want to consider reclocking the APFR and its settings out here first before you take it off or take the whiff extender off.
Okay, I'm ready for, I'm going to jump on the arm and then I'll be ready for all the different comms. So what am I looking for on the APFR first?
Okay, so it's 3 Quebec, Fox 3.
Quebec, So clocking of 3.
A-firm. Clocking of 3 if you want to start with that. Don't forget to ret to it.
Yeah, of course. Copy. Clocking 3, Quebec.
Sorry about stepping in your GTA there, Luca.
And Drew, the GTA is complete, so you got all the comms you want.
Yeah, no, I'm sorry. I stepped in there.
Yeah, no problem.
So we have that bag is here. Everything's on the correct tether points. It's the 2 large smalls and a small adjustable, holding it in place. I'm looking back at the work site, and everything looks good. I don't see we haven't left anything behind. APFR, it's the original configuration with the ingress 8 folded over.
Okay. Yeah, we watched you through that. We concur. It looks like everything's in a good config. You can start your transition back to the airlock. Remember the CEDACAR brakes.
It's good words from Andrew Morgan, completing his task for checking the inventory of all the bags of tools and tethers that he has used throughout the duration of today's spacewalk. And over to the left of his camera view there, you can see the foot restraint that he's been using. Back in its original position, everything looking good there, and getting the okay to make his way back to the Quest airlock. In the meantime, Luca Parmitano working at the end of the station's robotic arm to remove that foot restraint and get that deconfigured from its configuration for the alpha magnetic spectrometer repair spacewalks. Both spacewalkers are very much ahead of the timeline, working through their primary procedures of installing a new pump box. This is the new pump system that'll provide cooling for the alpha magnetic spectrometer, and swaging or connecting all of the tubes that had been cut prior to today's spacewalk and getting it ready for integration with the new pump system. Of course, one more spacewalk to go to check for leaks before the alpha magnetic spectrometer is powered back on. For now, it'll remain in a dormant state just to make sure that everything is safe to actually power it back on. The pump box itself, though, receiving power and everything looking good there.
Okay, clocking of 3.
Quebec,
Step
Quebec,
3, and then you
Quebec,
back to back.
box 3.
Right, clocking 3.
And just check the black on black good pull twist test.
I got back on back, good pull and good twist.
Cabby.
All right, thinking I've passed by my APFR. It's black on black. All the settings. 6 India, Kilo 12.
Copy, Drew.
Quebec and locked.
Okay, and then just double check that pitch knob is locked, can push it in.
And I confirm that it's locked, pushed in.
Copy.
And then I have
Foxtrot 3.
and I have 3, yeah, already done. Okay, what about now the width extender?
Okay, width extender is 10. Alpha 1 is going to be the final config, so Alpha 1 is what you're looking for.
Okay, so all the way retracted.
Okay, Luca, just do me a favor. We're confused about the comm. We heard about the knob on the APFR. Were you saying it can be pushed in? You were confirming that it could be pushed in?
Yeah. The knob on the APFR is locked and pushed in.
Okay, it should not be pushed in. It should be out and able to push in. It should spring back out.
Yeah, it's out and able to push in. Confirm.
Okay.
Concur.
Good words. All right, so
Sorry about that.
no, that's okay. I misunderstood it. So back to Alpha 1 on the width extender, and then you can pick that up, and we'll take it back to airlock width 11.
All right, I have Alpha 1 on the width extender, and I'm ready to pick it up after I retrieve my second safety tether.
Luca Parmitano continuing to work with that portable foot restraint to get it in a configuration where it can be properly stored. Final part will be to remove it from the Canadarm2. In the meantime, Andrew Morgan completing his tasks and checking his inventory and putting back his foot restraint on his way back to the Quest airlock.
The brakes on the Cedar cart and heading back home.
Yeah, check them on that side. I'll give it another. Okay, I have retrieved the APFR on the width extender. Toggles are out. Doors are closed. And I'm starting my translation back.
Okay, Luca.
And with that, the foot restraint removed from the Canadarm2. The task of the Canadarm to maneuver Luca Parmitano into the right position for working with some of these intricate parts of the Alpha magnetic spectrometer complete, stored on the external platform there. Parmitano getting a chance to glance at the Earth below. 256 statute miles directly below is the northern border of Colombia.
What's your position?
I'm above you on the cedar rail. You need?
Nothing. I was just wondering.
Yep, I'm about to come down cedar rail. Back. Oh, you're to your right side. Look at me.
A view from the helmet camera of Luca Parmitano. Helmet camera number 11, the translucent numbers at the bottom right of your screen.
Cedar rail coming down.
In tow by Luca Parmitano is that portable foot restraint that's been attached to the arm. He'll be again storing it or stowing it on the outside of the space station before he goes back into the Quest airlock.
Just wait long enough for you to get past like the toolboxes will be good.
Coming into view is Andrew Morgan with the bags of tools that he's been using and working with Luca Parmitano through the repair of the Alpha Magnetic Spectrometer today, making his way back to the Quest airlock as well.
It's probably just as good as the manure as your bead bag. Just start to go slow.
Puerto Rico and the Dominican Republic directly below Luca Parmitano at this time.
Your safety better.
Okay, let me put eyes on it.
Okay,
yeah, it's at the right across the toolbox. So,
okay, am I clear of it?
Your head is clear of it. You keep coming more and more port, or we're going to be clear of each other. And then once you get on the wagon wheel, we'll be clear of each other.
Your position is towards my neck.
Yeah, I'm slowly going to make my way down there, but I'm still keeping it out of your way. I have an eye on it.
I'm working on my fair leads. They're out of your way.
All right. As you come up on WIF 11, Luca, it's clocking of 10.
Yeah, WIF 11. Clocking of 10. Okay, copy. The local down.
Okay, I'm right behind you.
Yeah, I saw you. Jeremy, can you give me the clocking for the double line?
A firm. So it should be 4, I think, Luca.
Clocking of 4 on the double line, thank you. Okay. The brief is, funnels are out at 4, black on black, good pull, twist.
Okay.
And verify that it's 10 on the single line. And before I leave, I'm going to double check also that the APS is good pull twist test on the expander. Okay, the whole structure is good pull, good twist.
Parmitano attaching that portable foot restraint to the work site interface just near the Quest airlock. You're getting a view from the helmet camera of Andrew Morgan currently pulling at the thermal cover of the airlock. Both set to enter back into the airlock here shortly.
It's open.
Okay, looks good, gentlemen. Drew, I see you heading inside with the green bag. Luca, you can follow him in.
All right, that's my leg.
Your time.
That's my 6, 10 look. Okay.
Okay.
All right, I'm going to get in and get my waist tether. A waist tether to the D-ring extender in the airlock, box black on black. And give me 1 second to get situated so this bag is when he obtrusive.
That's right, take all your time, man.
Five hours, 46 minutes into today's spacewalk. Andrew Morgan back in the crew lock of the airlock. Parmitano will take up the rear. Once repressurization of the airlock begins, that'll mark the official end of the spacewalk. We'll come back with statistics for what's been done so far aboard the International Space Station and this year.
We just wanted a picture of you. Did you get any of those?
No.
I took plenty of pictures of him, but let me know if I can take any pictures of myself, so I'll do it. I think what he meant is that if you want to send us somewhere to take a survey, I think do that.
Checking.
All right. Otherwise, I've got the Arch 4U bag in here, and it's on a ret. In the airlock.
You're connected, Drew.
I gotta go ahead and connect my SU.
Okay, yeah, we're going to come inside. I just got to catch up with you guys on your safety tether config. I heard you were on your waist tether was good config, Drew. Luca, what's your config?
I'm attaching my waist tether, Drew's safety tether.
Drew, you're go to connect your SCU.
Okay, copy.
Okay, my right hand side waist tether is locked black on black on Drew's safety tether, which is also locked black on black. So I can remove my anchor and whenever Drew is good for me to go in, I'll be able to go inside.
Right.
Standing by.
Good for us, as long as Drew's is ready.
I'm going to make a small adjustment to my ECV. I think that was a little aggressive.
All right, Luca, I'm ready for you to come in. My SCU is on and locked.
Copy, Drew.
You ready, Drew?
I'm ready.
Okay.
Trying to position the bag kind of like the pump.
Okay, and Drew, just confirm your SCU is locked.
It's on and locked.
It's getting put you on the thermal cover.
Okay.
Andrew Morgan already inside the crew lock today. A view from the helmet camera of Luca Parmitano closing the thermal hatch and beginning the procedures for repressurization.
You closing the thermal cover. Reminder about the Velcro strap. Just see you working.
Thermal shut. The thermal cover is closed with the Velcro shut inside.
Okay, next for you, Luca, is your SCU.
Copy SCU. Making work. MSU is connected.
Okay, confirm it's locked. Then you can take your water off.
It's locked and the water is coming off.
UV2 water off.
Okay, 2-minute timer. Luca, you can just verify the hatch is clear.
I'm going to adjust my temperature. don't incur in any self.
Okay. Good words, Luca. And that is the next note is TCV setting of 8 to max cold minimizes your time for cooling.
Okay, and yeah, the hatch is clear, and now I need a little space to rotate. Do you think you can give me a little bit of clocking?
Yes, and which, yeah, the usual clocking.
Yeah, whatever you can give me.
Correct.
Okay. And Jeremy, whenever you give me the go.
Okay, Luca, we got another 40 seconds before we can close the hatch.
Copy.
Five hours, 55 minutes into today's spacewalk. Luca Parmitano and Andrew Morgan inside the crew lock, working through their procedures to close the hatch and begin the repressurization process. Soon the two spacewalking astronauts will be speaking with Christina Cook on the other side of the hatch, who will guide them through the procedures for repressurization, which will mark the official end of today's spacewalk. Jeremy Hansen, the ground IV, in the meantime, carrying those two spacewalking astronauts through the final steps before handing over to Christina Cook on the inside.
Drew, while he's working that, on the UIA, you can take oxygen, or you can check that oxygen EMU1 and 2 valves are open.
Open both, EMU1 and 2.
Hatch closed, latched, and locked.
Copy. Drew, you can switch power EV1 and 2 on. Check LEDs and volts.
Power EV1 on with a green LED, 18.6 volts. Power EV2 on, green LED, 18.6 volts.
Okay, for both of you, switch power to SCU. Expect a warning tone.
Yeah, E1. Over to SCU.
EV2 SCU.
Okay, gentlemen, I'm going to hand you over to Nana and take you the rest of the way back inside. You guys have to say you made that look easy today. Really nice job. We're in a good posture to get AMS up and running on the next EVA.
And Jeremy, as we always say, your space flight is about technology, science, and exploration. I think that today, with this EVA, we cannot put to practice the three of them. Technology, it was demonstrating the development not only of the pump, but also the fact that we could install it and swage tubes that we had cut specifically for this job. And that was, I think, a great technological demonstration. Science, obviously, put all this work into restarting AMS, the most important astrophysics experiment on the International Space Station, and hopefully giving it many, many more years of science. And exploration, because science is exploration in this case. We are exploring the farthest and most unexplored part of the universe by proxy using science. So congratulations to all those that worked to achieve the CVAs and the point that we are at. And hopefully with the next CVA we'll find out that all this work was put to good use. Thank you so much to everybody.
Thanks, Luca. Great words. The team very much appreciates that.
Luca and Drew, welcome back. Phenomenal job today. You guys crushed the timeline, and it was awesome watching you work. For both of you, you can take your O2 actuators to press.
Okay. It worked.
It worked. I'm impressed that my DCM is blank.
And so EV2 is impressed without the verification on the DCM. And Luca, what's your O2 actuator status?
Now the jiggle it, I'm impressed.
Copy, you're impressed. And Houston station on 1 for DCM.
Okay, we're back with you on 1. And can you just confirm the question? We're expecting that config for where we are in the steps.
Okay, copy.
Okay, so to clarify, you are okay with Drew's DCM being blank and his confirmation that he's impressed based on the location on the front.
I'm checking, Nana. Okay, that's a good config. Just make sure he's physically confirmed its location. We're handing over in 20 seconds.
Be coming up on the handover. Luca, you can verify that the EV hatch NPEP is closed.
Close.
And I'm going to take the IV hatch equalization valve slightly open. As discussed, I will take initiation of any rate changes from you guys.
Copy.
In a short handover of video and audio communications from the International Space Station should be regaining shortly.
You can increase the rate.
Copy, increasing.
I feel good, man. I just wanted to confirm, though, I would normally be able to have a DCM display at this point.
Yep, I concur as well. And while we're repressing, we can clarify with the ground if you'd like.
Yeah, I mean, I'm fine. I'm certain I'm impressed. I've jiggled it. I'm not getting any purple tones. Clearly, the ECWS is still working because I did get a tone as I was making the O2 actuator movement to press, and I am impressed. I'm getting no audibles right now.
Okay, I concur, and I can see your pressure gauge is a nominal pressure, about 4.3. Houston Station on 2, we just wanted to double check with you. Typically, the DCM screen would not be blank at this time. We do think we're in a good config with Drew, but again, just looking for your words on anything he can do or any feedback on the situation.
Yep. So, Nana, we think your assessment is correct. We would normally expect to see it. We're wondering if his display is locked up. But we do see that we are in a good config. Yeah, and ground telemetry is backing all of that up.
And Drew, I'm assuming you copied as well?
Yeah, I copy, and I'm comfortable if they're comfortable.
Okay, then we can increase the rate.
Copy, increasing.
And I just want to clarify for all of you that we are making this assessment based on the data we're receiving on the ground.
Okay, copy. The big thing is I just want to some additional confirmation that my O2 actuator is in the correct position, but it sounds like we're good, and nominal pressure, I feel fine, contact cooling, all is good. The EMU, I got 18.5 volts, and power switch is in on position with the green LED.
Okay, Drew, we concur with all that. We see a good config.
Copy.
And Luca, for you, since Drew normally had been reading out the pressures of the crew lock, if you could read out pressures at every 1 psi or so.
Copy. We'll do that. And what's the position of the repress?
We're about 50% between off and norm.
You can go a little faster. Drew is okay.
I'm okay.
Copy, increasing. Okay, we're at about 60% now. We're showing about just over 1 psi.
I'm at 1% these moments.
Say again, Luca?
1 psi from my DCM.
Yes.
Now you can go about 75% norm.
75?
Yep.
And that's about 75.
Copy. How's it feel, Drew?
Christina Cook guiding the two astronauts through the repressurization process underway confirmed a completion time of today's spacewalk at 11:33 a.m. Central Time. That puts the total elapsed time of today's spacewalk at 6 hours and 2 minutes.
Copy that.
And now you can go full norm.
Copy, go into norm. I went ahead and just went to about 90%.
Okay. .7.
See?
That's 3. DPSI.
Copy 3. For awareness, you should have an alert tone around 4.0. And at 5.0, we'll be pausing the repress. And we are coming up on 5 psi. I'll be pausing the refresh.
Copy.
Copy.
5.0.
Heavy hatch equalization valve is off. We're now waiting 2 minutes for the pressure to stabilize.
Now in a holding period on the way up from vacuum back to the pressure of the International Space Station at 14.7 psi, holding at 5, just to check for any leaks before we go all the way up. In the meantime, we have some statistics from today's spacewalk, timing out at 6 hours 2 minutes. This is the 224th in support of space station assembly and maintenance. It's the 11th spacewalk that's been conducted at the space station this year. The 5th for Parmitano, totaling 26 hours and 53 minutes in his career. For Morgan, this is his 6th spacewalk, totaling 39 hours and 2 minutes. Today's spacewalk lasted 6 hours and 2 minutes. That brings the total spacewalking time through space station assembly and maintenance to 58 days, 15 hours, and 43 minutes of spacewalking time.
Okay, that was our 2-minute stabilization. Now we're doing a 1-minute leak check. This is on us. We're just leak checking the crew lock itself, so no need to look at anything on your GCMs.
Copy.
Copy.
Still holding at 5 psi on the way up to match or equalize with the pressure of the International Space Station at 14.7, still holding at 5. We'll do a correction to some of the statistics. Here's the full slate. A correction to the Morgan's total career spacewalking time at 39 hours, 32 minutes. That's factoring in today's 6-hour, 2-minute spacewalk starting at 5:31 a.m. Central and ending at 11:33 a.m. Central Time. At the time that the spacewalk ended at 11:33 a.m., the International Space Station was 263 miles over southern Ukraine.
Going to AV.
IV.
EV1, AV.
You're both in IV, and I'm going to be taking the IV hatch equalization valve up to norm. Prepare for repress again.
Ready.
Ready.
Christina Cook resuming the repressurization process. Repressurizing on a normal rate, now exceeding 6.3 psi. She's the lead for the suit up and the repressurization activities for today. To her right, Jessica Meir, NASA astronaut, has been at the controls of the station's robotic arm through the duration of today's spacewalk, at the end of which Luca Parmitano conducting the primary tasks of installing the new pump system and swaging or connecting the tubes that had been cut on a previous spacewalk, clean cutting them and swaging them or pinching them to the new alternate fitting that allows the carbon dioxide to flow from the new pump system through the alpha magnetic spectrometer. The new pump system checked out its power, everything looking good. The AMS itself, the alpha magnetic spectrometer, will be powered up after the last spacewalk.
Which I just went from about 95% to norm all the way to norm. Let me know if that rate is not good. If it's too fast, I can take it back.
Copy.
Sounds good. We got 9.3.
Yeah, and we're showing the same.
Yep. Just fucking 10 now. 11.
Copy 11. Copy 12. And for your information, as we get close to DPDP of 0, you can expect an alert then.
Copy.
Copy. Copy, and we see the same. With that, we are going to be moving into post-EVA and opening the hatch.
Roger. Roger.
Andrew, if you could just verify those bags are away from the hatch mechanism as well as your helmet.
That's clear.
Station Houston on 1, just a reminder for watches, et cetera, when handling the suits.
Jessica Meir, assisted by Christina Cook, to her right, opening up the hatch. The pressure equalized between the crew lock, where the two spacewalking astronauts currently are waiting, to be pulled into the equipment lock, where Christina Cook and Jessica Meir currently reside. They'll pull the astronauts in one at a time and start removing some of their equipment that they're wearing now, including the SAFER unit. This is a simplified aid for EVA rescue. Provides propulsion in the unlikely event that the astronauts were to become untethered during today's spacewalk. And they'll remove the gloves and helmets from there.
Houston Airlock on 1, thank you for that. We took care of it. And can you confirm you are putting step 4 in work?
And you have a go, and step 4 is in work on our side.
Your report on when that's done and the crew isn't hot mic anymore. And the crew reported no glove contamination, so we're moving into step 7.
Copy all.
Andrew Morgan, the first one being pulled into the equipment lock by Jessica Meir, wearing the suit with no stripes, EV2 for today. The primary duty of handling all of the tools and equipment that needed to be brought over to the worksite. the alpha magnetic spectrometer, where Luca Parmitano at the end of the robotic arm was able to access some of the critical components today. Christina Cook on the left communicating with Andrew Morgan through the comm unit there. First things first, they need to remove that safer unit, simplified AIDA for EVA rescue. Now in a short handover period for communications from the space station, video and audio should be regaining both very shortly. In the meantime, Jessica Meir and Christina Cook will continue to assist the spacewalking duo to remove their suits. After getting Andrew Morgan into position, they'll pull Luca Parmitano from the crew lock where he currently resides. Do the same thing, remove the safer unit, which provides propulsion in the unlikely event that an astronaut were to become untethered. And then get him situated in the crew lock to continue removing gloves and helmets. The two spacewalkers completed a 6-hour, 2-minute spacewalk today. The primary task was to install the new cooling pump system onto the alpha magnetic spectrometer. Really, all the work that's been done so far was to prepare the alpha magnetic spectrometer for the work being done today. The first spacewalk in this series of repair spacewalks for the alpha magnetic spectrometer being all about access, installing handrails and removing debris shields and the vertical support beam where all of the tubes were, making sure that the work site itself was ready to continue some of the more intricate work, much of which was done on the second spacewalk. This included a rough cut of some of the tubes, pulling them out and marking them, and installing some of the equipment, routing some of the cables, getting ready to accept that new pump box. And that work was all done today. The new pump system, called the UTTPS, the upgraded tracker thermal pump system, that pump system being carefully brought out to the worksite, which had been prepared on the previous 2 spacewalks. A lot of intricate work to be done that was done during today's spacewalk. That included installing the new box, plugging in the power and data cables that were previously routed, and clean cutting the tubes that were previously rough cut, and then swaging them with an alternate fitting, essentially connecting them to the new pump system's tubes, making sure that carbon dioxide can flow freely throughout the system, and which is the primary cooling of the alpha magnetic spectrometer. There's one more spacewalk left. The work is not yet done. During that spacewalk, the same spacewalking duo will go out and go back to those tubes that they just fitted with the alternate fitting to the new pump system. On that new fitting is something called a visual leak indicator. One by one, they'll go and they'll inspect each of these tube fittings and just make sure that the work that they did today was sufficient enough to turn the alpha magnetic spectrometer on with the cooling system, and making sure all of that carbon dioxide is flowing as expected with the new pump system. The pump system itself was checked out from the ground, powering on and verifying that the pump system itself is working just fine. The last step will be to check those leaks and clean up.
You can't talk to us, but you can hear us. We're curious if your DCM is still locked up, if you wanted to cycle your display switch and give us a thumbs up or thumbs down if it's working or not working. Okay, 2 thumbs down.
DCM is still blank.
Thanks, Nana.
Christina Cook and Jessica Meir continuing to help the 2 spacewalking astronauts get out of their suits. After the completion of today's spacewalk, timing out at 6 hours 2 minutes. Again, one more spacewalk to go to clean up the work site of the alpha magnetic spectrometer and check the leaks of the carbon dioxide pumps. In the meantime, the alpha magnetic spectrometer will remain dormant. The next upcoming activity for the International Space Station will be the launch of the SpaceX Dragon cargo vehicle, carrying more than 5,700 pounds of cargo and science to the International Space Station. Critical science that the astronauts themselves will need to work on, set to launch this Wednesday, December 4th, and arrive a few days later, December 7th, for the crew to capture with the robotic arm and berth to the nadir or Earth-facing side of the Harmony module. After the successful arrival of the SpaceX cargo vehicle, the International Space Station program will determine the appropriate date for that last spacewalk to complete the activities of repairing the alpha magnetic spectrometer. In the meantime, the experiment will remain dormant in a safe configuration, but just want to make sure that those leaks or those fittings have been through proper leak checks before turning the system on and starting to gather the data where the experiment itself will be collecting particles from around the cosmos, cosmic rays, antimatter, and other particles, analyzing them through the powerful magnet aboard for scientists on the ground to analyze and search for the origins of the universe. Parmitano doing a lot of intricate work with his hands today. Of course, carrying the new pump system out to the alpha magnetic spectrometer work site via the robotic arm, situating himself in the foot restraint and carrying the 350-pound pump system out to the alpha magnetic spectrometer for installation. Much of his work with his hands, though, was with the tubes. Of course, after connecting the power and data cables to the new system, much of the work with his hands was used with some of the unique tools that were developed specifically for the repair of the alpha magnetic spectrometer. Some of these tools included a clean cutting tool to allow a nice uniform cut to those tubes and allow them to fit nicely with the alternate fitting, which swaged the tools or sort of pinched them and joined them together with the pump system's cooling tubes. Very intricate and repetitive work, what with the clean cutting as well as the straightening of the tubes with a straightener that also provided a measure. Then using his fingers to tape the tubes at a very specific part of the straightener. And that tape let Parmitano know exactly how far to push that tube into the fitting. He had to do this 8 times with the help of Morgan, who provided him the necessary tools, all of these different components through each of these steps, giving him the tools and the perspective. Throughout today's spacewalk, you may have heard many glove and hap checks. Of course, the gloves themselves already been removed. In Parmitano's left hand right now is the hap. That's the helmet absorption pad, complete with the communications unit he used throughout today's spacewalk. But that helmet absorption pad would be used in the event that there were to be a leak inside the suit. That helmet absorption pad would absorb some of the moisture. But those regular checks to make sure that the gloves are not scuffed up too much and that the helmet absorption pad is dry relatively.
One for Luca's multiple water connection to his LCVG. We have some evidence of water on the multiple water connector side on the tube that is closest to the top of his body. We approximate about maybe 10 milliliters of water. We did get photos and we did dry it.
Copy all. Thanks for that. You're go to continue. an Airlock Houston on 1. While you're sitting there looking at that, do you think it is a leak, or are you thinking it's condensation? Or you don't know. I see Luca's response.
I think that it had the signatures of being a leak because it was a kind of a singular blob of water that was located in one place.
Okay, copy. That's more helpful than Luca's sign language.
Copy.
Now, through the process of Christina Cook and Jessica Meir working to remove Luca Parmitano from the suit, inspecting what's called the LCVG. That's the liquid cooling and ventilation garment. Runs water throughout Luca Parmitano's body and can be adjusted temperature-wise for temperature control, as air conditioning is not as effective in the vacuum of space or in the microgravity environment. Now, because liquid water is running through that tube, regular inspection of the liquid cooling garment is needed, and the crew are to report any signs of water that may be coming through. They reported a small amount of water, estimating about 10 milliliters.
Houston airlock on 1, I can report that we do not see a lot of condensation or water otherwise in the LTA or the HUT, and we also didn't notice a whole lot on the LTVG behind where the apparent leak was on the multiple water connector.
Great words. Thank you very much.
Luca Parmitano out of his EMU, his extravehicular mobility unit. Christina Cook and Jessica Meir working with Andrew Morgan to remove his suit, and we'll do the same inspections. With the helmet off and the gloves off, we'll wrap up our coverage of today's spacewalk that timed out at 6 hours, 2 minutes, where Andrew Morgan and Luca Parmitano completed the installation of the new pump box, the pump system to the alpha magnetic spectrometer, and swaged or connected all of the tubes ready to start flowing that carbon dioxide to the alpha magnetic spectrometer. A few things first before that happens. The SpaceX Dragon is set to lift off from Florida this Wednesday, December 4th, launching at 12:51 p.m. Eastern, 11:51 a.m. Central, with 5,700 pounds of cargo aboard. It'll arrive at the International Space Station December 7th, this Saturday. Commander Luca Parmitano will grapple the Dragon with Andrew Morgan acting as a backup. After the 5,700 pounds of cargo is installed at the nadir or Earth-facing side of Harmony, crew will access the scientific experiments inside and conduct the critical time-sensitive experiments that are aboard Dragon. Upon the arrival of the SpaceX Dragon, the International Space Station program will assess the timing of the fourth spacewalk for the repair of the alpha magnetic spectrometer, which is critical and involves leak checks before the system itself is turned on to continue collecting data. We hope you stay tuned for some of our future coverage for the SpaceX Dragon and upcoming news for the fourth spacewalk of the alpha magnetic spectrometer repair. That'll wrap up our coverage. This is Mission Control Houston.